All right, so what we talked about we're going to pick up on a quick tool that we left off with yesterday called Quick Profile. And it describes it on page 35. And it's a way to, let me see, I'll stop video there. There we go. So it's a way to evaluate things in your drawing to make sure that to make sure things are at the proper elevation so you can check and see if there's problems with things. And I want to show you something now. Marissa, you had asked if we're going to use anything that we'd worked on prior. And in that sense, no, you didn't need to save anything, but I am going to have you load that drawing back up again so to show you an example of what I'm talking about using this tool, because it's a really, really good evaluation tool for data and for surfaces and things like that. So with that, I'm going to share my screen so you guys can see the see this book, right, about Quick Profile. And then you should be able to see this. So now I'm going to go ahead and load this file up, sample from T3 Global. You can do the same thing. It's in your folder. It does not have to have been processed. In fact, I will just freeze off this image so that it's not in our way. And if when it comes up, you have all of these, let me freeze this again. Oops. You have all of these break lines on. So here's what we've got. Okay, so you've got all of the white three-dimensional break lines as well as the drawn contours, etc. So what we're going to do is we're just going to take a look at just this area down in this corner, for instance. And I'm going to have you freeze these two layers. So I want to go to the view menu and choose freeze layer by pick. And I want you to pick, let's see, I guess you got to get the right tool. The view freeze layer by pick, and then pick on one of those white lines that you see, and then pick on one of those pink dots so that you're left with the contours. Okay. And then I would like you to go to the draw menu and let's draw a rectangle. It's the fifth command down on the menu. And just start down here in the lower left corner and go up enough to include, that much, like that. That's fine. Something like that. It doesn't have to be exactly like that. And we're going to use that as our inclusion area for building a quick surface in just a minute. Now, let's go back to the surface menu and choose triangulate and contour. And what should be good practice for you is always when you run this command, or at least at the start of the session, look at the selection tab at the top and make sure that nothing is checked unless you specifically want to filter the data or only use points or something like that. So everything's unchecked. And then I also want to go to my contour tab and uncheck draw contours. I don't need to draw them any further. I'm just going to build a surface from it. I'm going to go back to the triangulate tab and I'm going to turn on right triangulation file. And then I'm going to choose select. And I'm going to call this EG for existing ground from contours and say save. And because we now have an inclusion area, we're not going to take all of the data. We're just going to look within this one area. I'm going to check on to use the inclusion area. I will ignore 0 elevations. I'm not going to have any of these other things checked. I'm going to have my interior and exterior distances set to 2,000 feet. I don't need to densify the break lines, and I don't need to interpolate ridges and valleys, minimize flats, interpolate summits and pits, or interpolate valleys. Now, why they had that in there twice, I'm not sure. I've never had that successfully explained to me, other than this one is on the lower right is specifically meant for when you're doing contour data, whereas the one on the upper left, it doesn't work on the data before it builds the triangles. It works on it after it builds the triangles, but I'm not sure exactly what that does. Simplify surface. If you've got a huge area, and I had a job like this down in Eastern Virginia where they were building an expansion of the nuclear power plant at Anna River. The contractors, the surface data that they were building was too big to fit on the controllers for their excavators. And so we had to break it into pieces, and then we had to simplify the surface. And so what that does is it builds that very complex surface, and then it tries to weed it out to a more minimalist condition to have less data. That's all that's for. No need for that for right now. So I'm just going to have this. I'm going to write the file. I'll use the inclusion exclusion area. I will ignore zeros. I will have 2,000 feet as my mins for, or my maxes rather, for interiors and exteriors. Nothing else checked. My contour tab is unchecked for draw contours, which means my labels tab is completely gray because I'm not drawing any contours, therefore can't label them. And my selection tab is unchecked as well. So I'm going to now say, okay. And I'm going to read the prompt. I'm going to read the line above. It says select entities. And I remember when I was first learning this command that every time I saw that prompt, I would haul off and just grab everything on the screen. But it changes as to what it's asking you to select. So be sure to read the line above. It says select the inclusion perimeter polylines, more than one possible. So I'll select that square. That's the only one I have. So I finish the selection by pressing enter. And now it says select entities again, but it's asking for something different. It wants exclusion perimeter polylines or enter for none. So I just press enter. And now select entities one more time, select the points and break lines to triangulate. And I'll just draw a window around everything and hit enter. So off it runs and it creates that surface. Okay. Now,
you're gonna have to hold on.
Okay.
Mine actually didn't do that. Since I guess since I'm running an AutoCAD, it asked me to select objects, and then I picked it, and then it went on, and then it just kicked me back out.
Oh, okay. Well, you have the rectangle drawn there, right?
Yeah. Yes.
Okay. All right. So let's go back through it. Go back to the command on the surface menu, triangulate and contour. And make sure that it does have checked on to use inclusion exclusion perimeters. And then hit OK.
Okay. And then it says select objects.
What does it say on the line above that?
Hold on, let me pull it up.
Widen out your command prompt window if you need to.
It says select points and break lines to triangulate.
Okay, that should not be saying that. I'm gonna, let me have you share the screen. I'm gonna stop. this share. And you go ahead and share your screen. Let me take a look at what it says. If you hit your share button and you select that screen, you also have to hit the share button again down at the bottom once you select the screen. Yay, nay?
It says your screen sharing is paused, and then it says resume share. I hit it,
Yeah.
and it's not. Once
Try it again. I don't know what's going on with it. No, still.
it says I'm sharing. It says I'm sharing right now.
I'm not seeing anything. Let's see. Up there. No. Yes. There we go. Sorry about that. It was hiding.
That's okay.
Okay. All right. So, yeah. So, all right. So I see your screen here. And so let's go to the surface, triangulate and contour, and use inclusion and exclusion. All right. That's fine. You're writing the file. That's fine. And you choose OK. Now, see what it says on the line above? Select the inclusion perimeter. So that's where you select the rectangle. All right, so it found one. Hit enter to finish. Now it wants you to select exclusions, so you don't have any, just hit enter. And now select all your data. There you go. It's like going to the doctor, Fred. You know, yesterday my knee hurt so bad I couldn't walk. Today I'm doing jumping jacks. All right. So there it was. I don't know why or what was going on with that. But anyway, you've now correctly done that. All right. So you can stop your share. And let me put that down in the corner there, and I'll go back to sharing this one. Okay. Now, let's see here. Marissa, I take it you had yours with no problem.
Yep, I'm good.
Okie doke. Now, all right. So there we've built one out of contours. Now I want you to go back to the view menu and choose fall/on all layers. And I'm going to turn this picture off so that we have that. So now I've got those two things that we had earlier on that we froze. I've got them now showing again. And I want to also go back after I do that and choose freeze layer by pick. And I'm going to zoom in here and I'm going to pick one each of these contours. So notice that there are some contours, these dashed ones, they're on a separate layer. So make sure you get those turned off too. So now you're back to having these 3D lines and these points available, okay?
Yep.
All right, so now let's go to the surface menu, triangulate and contour, and we're going to change the name of the file we're going to save, right triangulation file. We're going to call this one EG from BK LNS for break lines or something like that. Say okay, go through the same process. Select your inclusion, no exclusions, and then select your data again. And by the way, you don't have to, and you'll get this error message, just hit exit. I'm not concerned about those little errors at this moment. You don't always have to select all of the data. You only have to select the data you want to consider. But because some of those lines might go, way beyond the edges of that little boundary, that's why I wanted to make sure I just grabbed it all just in case I missed something because it wasn't inside my selection window. So keep that in mind. It's asking you very literally to tell it what you want to consider to build the surface. All right, so now we have two surfaces. And I'll show you with our surface viewer, the
I
one. Oh, go
I
ahead.
have errors on mine.
Yes, hit the exit button at the bottom.
Okay.
Yeah, that's what I'm saying. I'm not all that concerned right now about clearing those little errors. That's something that we, you can do that on the fine-tune stuff. Right now, I just want to get these so we can evaluate the differences between them and use this tool for the quick profile. Okay. So now I'm going to go to the view menu and choose 3D view and my surface file viewer. And I'm going to look first at this EG from contours and open that up, okay? Now, there's all kinds of things that we talked about yesterday, like these triangles out here in this side that we didn't trim off. I'm not worried about that right now. And if yours looks like this, remember this little icon colors it in, okay? But the thing that I'm more interested in you to see is running down the edges of this road. You see those things that look like stair steps, right? Because it built that from the contours. Now I'm going to exit that one and I'm going to repeat that same command, but I'm going to choose the other surface. Oops, and I'm going to get situated correctly here. Let me put this in the right spot for me. And now I'm going to look in that same area and you see here where I've got the, let me change the light shadows here. So you can see the road edges are nice and sharp because it ran down those as break lines, okay? So those triangles could not jump across those edges. So you've already seen how
Am I supposed to be using the one with the contours or the other one?
I did one of each. I looked at this one with the contours to show you how ragged it looks. And then I exited and I ran the command again. And I looked at the one from break lines.
Okay.
Okay, so that's all I'm really showing you, that we know one surface is much better than the other, right? Okay, so in this case, we know the answers, but let's take a look at what we have and why we have the answers as to what they are. So let's go back to the view menu and let's turn thaw/on all layers. And I'm going to freeze once again those break lines. If I can get the right tools with the other command by freeze by pick. And so this is what my data would have looked like coming from my, my sub-consultant. I've got this nice road edge with these nice contours, and those contours are correct. If I walk up this contour line, I'm at that correct same elevation all the way up to this corner and then turn around and go back down here. But when it builds the surface from the contours only, it makes these areas in here flat because it goes from here across to here, and it fills that in and calls it the same elevation, and it clearly is not. Okay, so we're going to see the effects of that, and this is why we have to. That's why we have to use our brake lens. Go ahead.
It seems your screen is on the view control.
What?
The 3D view?
No, you're still seeing this. You're still seeing the 3D view control.
Yes, correct.
It must not have updated for whatever reason. I wonder if there's some kind of a lag. Now I'm back into it. Now I'm back into here.
Okay.
Got it?
Yep.
Okay. So what we have, what we're going to see is that when we're in an area here, when we built the surface from contours, we saw it jump across from, say, this vertex over to this vertex to build an edge of a triangle, and they're the same elevation. They're on the same contour line. So it thinks that there's a nice big flat spot right in here, and that's why you saw all those little steps in that surface that we viewed. Okay, but here's another way to look at all of that. That's what I really wanted to show you with this tool, is this quick profile tool. So we have 3 actual things that we're going to be looking at. We have things that are drawn on the screen. Those are called screen entities. And we have surfaces, and we have 2 surfaces. So that gives us 3 things to evaluate with our quick profile tool. And here is where the quick profile tool lives. It is on, if you look in the survey module, which is what I have loaded here is the survey module. I can tell because it says survey as the menu choice after points. On the centerline menu is where you can draw things that have to do with roadway alignments. These are the horizontal center lines, okay? But we're looking for profile tools, and you notice there is no profile menu. Now, if we have it, and I don't know whether you, Fred, you may have the civil package at your office. I don't know.
Yes, correct.
Okay, so if you do, I'm going to switch to the civil menu real quick, and you can look at it there as well. Notice it has a centerline menu, just like survey does, but it also has a profiles menu, and that's where that command lives in civil. It's on that profiles menu, okay? But if all you have is survey, you need to find it in a different spot. And where it is in survey is on the surface menu, and it's down here at the bottom. Just these bottom sets of commands are the few profile commands that they give you in survey. Either one, it's the same command. So I'm going to choose quick profile. Now, here is the way this command works. You have 3 possible choices for sources. You can either choose things that are drawn on the screen, or you can choose a drawn 3-dimensional polyline, in which case it reads the polyline and shows you that. We'll turn those break lines back on in just a minute, look at them. Or you can use a surface file. So for right now, let's choose screen entities, and let's say okay.
Hey, Ken?
Yes, sir.
Right now I'm using the demo 2020 version. Is that still, because I don't see on the survey one where the profile is.
It's on the surface menu. It's this bottom set of commands, right?
Draw profile?
It's on the surface menu. It's called quick profile. Do you see my menu open?
I do.
Okay. So if I'm on the survey menu, if you're on the civil menu, look under the profile menu. But if you're under the survey menu, look under the surface menu.
Quick draw surface. No.
Not No. Where do you see quick draw surface?
I'm in this, I'm in the surface tab.
Are you using the ribbon? That may be what you've got going on. I don't have the ribbons out. I'm just looking at the pull down menus.
I am looking at the pull down menus. I'm looking in surface and I don't see the quick profile.
All right, it should be exactly where I'm pointing to it on my screen. We've got the exact version going. You've got 2020, I've got 2020. And you're not seeing that?
No,
Huh. Well, how about share your screen again? Let me take another look at it. All right, I'm going to ask for remote control.
sure.
And once you give me that, so now I've got this open here. And yeah, so you're on the ribbon. That's this surface. When I said the menu, I mean these pull downs like this up here, okay? So on the ribbons under survey, let's see where you would find that. That's what I'm saying. I don't generally do that. So
Can we diminish the ribbons?
yes, and you do that by right clicking this gray spot up here
Okay,
and choose well, oh, you're using AutoCAD. That's why. All right.
Hey,
So if yes,
Ken, I think if you see that little white up arrow and down arrow.
yeah, that
Yeah.
lets you minimize and go through it. But instead of just minimizing it, I want to turn it completely off. And so if I say menu close down here at the bottom,
okay.
well, menu, menu bar. No, that's, wait a minute, menu bar is one, it's ribbon close, not menu close, ribbon close. There we go. All right. So now what I'll give you, what I'll turn out here is let's turn on the Carlson menus ribbon. It says that you have that on. There it is right there. Let's put that. I'll let you rearrange that to however you like it, but that way I'm at my survey, and then I'm going to look under surface and I'm going to choose quick profile. It's right there. Okay. So if, however, you did use the menu or ribbons, I'm trying to see if I can figure out where it is, because using the ribbons is really not a bad way to go. It's commands are grouped a little more logically that way. I just haven't, because they keep changing them, I haven't bothered to learn exactly where they all are. But under the setup, under draft, it wouldn't be draft. It's possibly an inquiry kind of thing, which would be, here's the inquiry menu, but that's not what I'm looking for. I'm looking for,
I actually don't prefer the ribbons, to be honest with you.
okay.
I'm a toolbar kind of guy.
All righty then. Well, that'll work. So we'll say ribbon close. And I'll let you work these as you see fit. All right. So
Okay.
I'm going to, I'll stop my remote control, and then I'm going to stop your screen share, and I'll go back to mine here. Desktop 2, share, and make that minimal again. Switch back to this. Okay, everybody see this okay now?
Yes.
Yeah.
Okay, so choosing that command, surface quick profile, we have 3 choices of source. We have screen entities, a 3D polyline, or surface files. And if I choose screen entities, go ahead and choose that and leave on ignore zeros. So if I cross like these blue and magenta and red lines down here, which are drawn down at 0, it's not going to pull my profile down to 0. I'm just going to ignore them. I'm going to say okay. And now look at your prompt. It wants you to pick a starting point, in which case you would pick, and then it asks you for another point, which you pick, or you can have already drawn it, in which case you would say P for polyline. It asks you to pick a polyline that you want to use, or you can type CL, which means it's going to ask you for a centerline file that you have already saved out on the disk. Okay, so we don't have any of those. We're just going to pick a point here, and we're going to drag across the screen, sort of perpendicular to the road, so that we're up here on top of this little cemetery area. And we'll click once again. And now notice it keeps asking you to next point, and you can make these lines go, you know, with multiple bends and stuff. But I'm just going to look at those 2 points, enter to end. So I'll hit enter, and there is my quick profile. It splits the screen, and it shows me a couple of things. And if I point the mouse up here to the plan view and roll the wheel around, or press and hold the wheel and pan and zoom, I can do that. I can't run commands while I'm in this one, but I can at least reposition my view. And if I move down here at the bottom, I see the blue crosshairs. And notice as the blue crosshairs are tracking on the profile on the bottom, over to the right, it's reading out the station and the elevation and the slope right up above it, and showing you what that is. Now notice, remember the source that we told it we were using was screen entities, ignoring the zeros. So the only thing it really did was every time that line that I drew crossed any of those screen entities that have any kind of elevation, it generates this quick profile. So you can see as it comes down the bank, that looks all good, but it gets down here to the bottom right there. And then look, all the way across the road, it is completely flat. And do you understand why that would be? Is because when it was tracking up here, when it built triangles out of this contour line and this contour line, it started, you know, it would put those in there as flat elements. But right now, we're not even looking at triangles. We're just looking at where it crosses things. So it crosses first over right there. It picks up that edge of that contour line. And as it goes across, the next thing it hits with elevation is the same contour line. So it's right there. And look at the bottom, look at the top. I'm in a completely flat zone. So the next thing it hits with any elevation, since I'm ignoring zero, is itself, which is right there. See the little marker in the top? Again, it's flat, keeps coming across, and it hits itself one more time right here. So if I were to use just these drawn lines as something that would govern what my surface is going to look like, that's going to be completely wrong. I can tell from the contours, and I know for a fact, just from experience, that that roadway is crowned and there are ditches on the side, okay? But this lets you look at that and evaluate that situation, okay? Notice on the right as well, you've also got the ability to change the vertical exaggeration. It starts out in fit mode, but if you want to see it without exaggeration, use the ×1. If you want to see a double, ×2. If you're really flat ground and you want to see it really steep, you get the idea. Okay. Now, the save, draw, and print buttons are exactly that. When you save this, it will actually create a profile file, a PRO file that has all of these stations that you're seeing over here on the right-hand side, paired with the elevations at those stations. If you choose draw, and go ahead and do that, just choose draw and take the defaults, just hit OK and hit OK, and then go off to the side somewhere and just click it down. Now, yours may or may not look like mine, but it's going to generally give you something like that. It's going to have stations, it's going to have elevations. Yours might be vertically exaggerated like 10 times or something.
Mine says function canceled, error number 2.
That's probably something to do with the fact that it's a demo version.
Okay.
Not sure.
Okay.
Try that at home and let me know what goes on with it.
No problem.
Or not at home, but on your regular licensed version. All right, so that's a way that, and if you don't draw this, you're not going to be able to keep that and save it. So, and there's no real need to draw it if you're just evaluating things. Okay, so that's drawing from the screen entities. Now, let's run the command again. And it's down here, quick profile. And this time, let's choose surface file. Now, when you choose surface file, you have to come down here and tell it what surface or surfaces you want to look at. And it always leaves in this list the last ones that you had the last time you ran the software, regardless of what job it is. Okay. See, that was Butler Area School District Drainage Project, Future Ground Repave Modification 10. So, these don't make any sense. So I'm going to, first of all, I'm going to only look at one surface. So I'm going to go to the second surface. I'm going to click that button where it says second, and I'm going to just immediately hit the cancel button, and that'll clear that off. Now I'm going to hit the first button, and I'm going to choose that EG from contours and choose open. Okay. And so that's now mine that we just built from the contours the first time, and I'll say okay. Now, because I'm using a surface file, it's going to be a little bit different. I'm going to go try to get close to that same spot. It's going to ask me a starting point. So I'm going to come down the slope and come across and up here over into the cemetery area, sort of perpendicular. Click, I'll hit enter to finish. And now, you see, I get a little bit of the crown showing, which is what I expect, because when it's building that triangle, it, at least in this area, if you see down here below, let's put a 2-time vertical. That's too big. Let's just, all right. So if you see here now, I can pick up a little bit of that. I come down here, I hit what should be the bottom of the ditch, and it comes across. But if you're looking really close right in here, you see that that's showing that ditch is being flat across here, and it's really not. And then right in here is where it starts to pick up and start to show the crown a little bit better. Okay, so it's starting to pick up and show that crown, because what's happened is when it built triangles in this area, it went back and forth between itself, and those triangles are indeed flat. But when it got out in here, it started to pick up and see these points on this other contour line. So it started to pick up some of that elevation difference. So it built some triangle edges this way instead of always, going across this way. okay? So that gave us a little bit better than, just looking at, absolutely nothing in between the drawn elements. But let's now take a peek at that same thing. I'll exit this and let's run the command again, keeping the same choice as surface file. And this time I'm going to click that first button and I'm going to choose EG from break lines. And just to show you that it can give you two, and this is the nice thing about this tool, I'm going to hit the second button and go back to that EG from contours. So now I'm going to say okay. And I'm going to try again to sort of pick that same area. And now look at this differential. And I don't think, yeah, that's not going to really give us much to take in there. But if you zoom in down here in the ditch, the first surface that we chose is the surface in the break lines. That's there. I'm sorry, is the this white one is the surface in the break lines. And you see as it's tracking, as all I'm doing is hovering the mouse back and forth here. And as I hover the mouse, the crosshairs track along that white line. That is the first surface, and that was the one from the break lines. The red surface is the one we chose as the second surface, and that's the one that it's just showing there for visual reference. But everything you see over here on the side, the station, the elevation, the slope, that is all that first surface. And so there you can see the difference right in there of how when I use the break lines, I got more of the ditch. You see how it goes deeper and the red line was flat. That's that flat area. I got over here and I've actually picked up, the road has a bit of a ripple in it right through there. Again, my white one is the correct one. The red one is sort of generalized. Now look over here. As I get to the edge of the sidewalk, I can really see the difference, okay? So now you see the importance of using those break lines instead of just contours. Now, I've been ranting on and off and on and on, or not on and off, I've been ranting on and on and on about break lines, break lines, break lines, we're gonna use them. And I understand you all know that break lines are important when you use them, but the key point that I want to show here is that sometimes if you don't have the break line data, then sometimes what you can do is you can draw it in. You can draw it in, say, between that peak and that peak, and just draw down between all these lines and manually put in those break lines and snap to those contours, and you can build them yourself. But that takes a long time to do. There are some shortcuts that you can do with some things, but that takes too long if all you're trying to do is generate a bid on this job, right, Marissa?
Correct.
So you have to recognize the fact that, well, okay, my surface isn't exact. I'm not going to build anything from this, but I can use it probably well enough to make my bid, my estimates, my earthworks. Because right here's an example. It's not a very good one because it's I had hoped to have a little bit difference. It's all one-sided here almost, except for that little peak. But in general, when we do something like this, the places here where it is showing my bad surface is showing too much ground. There are other places like right in here where it's showing too little ground. So on average, that tends to balance out. And so volumes, oddly enough, tend to be, not too far off, because where it's over across the job it tends to balance out where it's over versus where it's under. Now, another thing about this tool that's really useful and helpful for you, I'm going to show you right here as well. I'm going to roll out, zoom out a little bit to where we can see this whole thing and this whole thing down here. And when you are using surface or surfaces under this tool instead of screen entities, you have a new button right here called Adjust Alignment. So if you click that, notice up here in the prompt area, it says pick the alignment point to adjust. And there are two cases. You can pick near one of the points, which in our case, we only have end points. If we had a bend in our line, we could pick near the points. And that's like grip editing a polyline. So if I pick near this point and swing it, you see it keeps the other point where it was. And then once you do it once, you have to go back and hit this adjust alignment again. But if you pick, and you don't have to snap to these, but if I pick nearer the middle, now I can move this thing around wherever I want to and watch the profile as I'm moving this. See what it's doing? It's letting me take a look at the relative, the differences in the surfaces. Everywhere I'm sliding this along, okay? See what else is. I want to.
I have a question. So
yes,
with when you went down further on the road, I noticed that the red was like it dropped off pretty large compared to the white.
Like right there.
Yes.
Right? Okay, I'm going to click and put the thing down so it's sitting there. And I want you to look at this. Watch where the crosshairs are tracking and watch where the marker is up in the upper part. I'm going to go over here to the top and I'm going to come over here and you see where I am right there? Now, what lives out here? If you remember, first of all, the two surfaces, the white surface is the one from the contours. Okay, so I'm running out of data right there. I'm sorry, the white surface is the one from the from the brake lines. The red surface is the one from the contours. But remember, we had all of those triangles that it built down here on the bottom that were just sort of bogus. So
yes.
if I were to plot or draw this surface that was generating that, you're going to see those long, skinny triangles that come out here. And remember, they go all the way out to this edge. So they're, those contours down here are lower than they are over here, but it stretched it up. And that's what made this look like it fell down. So, the real rule of thumb is that when you're near the edges, things are going to sort of fall apart. But it's actually reading the data that got created. Okay, so that's why, if you remember the contours, these green and yellow contours that they provided us, remember all the data, the brake lines and the pink dots were about 50 feet outside of this trimmed off line. And that's why they do that. Because when you get out here, you start to get into where those edges don't really make a lot of sense because there's no more data to extrapolate it to. And it just it goes to the next data point, which is not anything there. So these white lines, or rather the white line is actually reading the brake lines, which are further out here than the contours are. And that's why these contours drop down to well, not entirely zero. In fact, if I go to, it's like that. So I'm up here on the top. Notice I'm up on top of this little hill pad, this cemetery. But when I get off to the edge here, it's going to drop down to this relative level here, which is the same as this relative level here, because I've run out of data in between there.
Okay, makes sense. Thank you.
Yep. So now, so you can see, like right in here, that little difference. But let's take a look at it one further step. I'm going to adjust the alignment. I'm going to click near the end, and I'm going to click right in one of those contour points. And I'm going to go back here and say adjust alignment. I'm going to grab the other end and I'm going to come down the road a little bit and click right in another one right in there. Okay, so now I've got this line running like this. I'm going to click adjust alignment one more time, click near the middle. I'm going to sort of position it out in this area in here. And when I do that, now look at this down below here. And let's go back to fit. Okay, so you see the difference? There's those steps. That's all of those places where it got flat as it built flat contours across there. Okay. And I look at that and I can see that same phenomenon over here. You see that difference there as well. I hit adjust alignment. Let me put this a little closer to the there we go. Okay, and there's a better example of how sometimes it's under, sometimes it's over, under, over, and so they'll tend to balance things out a little better. That's why when you're doing this for estimating purposes, it's not worth the time to try to do all that unless you have a situation like, and we didn't include it, but remember that big exit ramp that we had up here? That would be too much of an error to ignore. So, but you would see that if you use these tools, and if you're suspecting there's a problem up there, you know, run that quick profile, zap across there and see what's going on with it. In fact, if I take a look at that, I still have that file. So do you actually, if you built it yesterday. And I'm going to run a quick profile. And this time, instead of that surface, I'm going to change my first surface is going to be my EG4. That was my last good one, I think. I'm going to say EG3. And I know my bum surface was EG1. That was the very first one I did. Okay. And I'm going to look at this, say, from here to here. There we go. You see that? If you remember, I had, you know, it ran out of that, see, there's that retaining wall. So you see the difference in those two surfaces. Remember, the white one's the good one. The red one's the bad one. And you can see, let's just take a look across the wall itself. You see, there it is. They're sort of good right in there because I've got contour data. But when I come down in here, I watch what happens. You see that red? There's that ski ramp. That's all that extra materials, and that's a situation. That's a case where, you know, you would need to probably resolve that. That's a lot of dirt. Okay, that's 50 feet in horizontal extents, and it's 10, 50. It's 10 feet tall. So, you know, that might throw off your numbers a little bit, or it might not. You know, if you're also building the interchange for the turnpike, you're not going to care about a couple of truckloads of dirt, but you know, you just gotta use the right judgment. Same thing. Here's my looking across the pond. You see the difference in the pond versus how accurately it's done. Let's go in here and get the pond a little better. Okay, now remember, I didn't rebuild those surfaces this morning. They're left over from yesterday. Okay, so that's the key thing to remember from all of that is when you save that file, when you choose write triangulation file, you have that data and you can always go back to it, even if you're not even in the same drawing file. It doesn't have to be associated with it at all. it just loads up the file and it shows it to you. Now, it's a good thing we have this file so I can use some visual reference to see what I'm looking at. Okay. There's another instance right in there where we got some differential. All right, so you get a sense of how you can use this tool as a real quick evaluation. And if you've got something that you're looking at, you're not, let's say like we're right up here, we got something right in here that we're looking at. I don't know, you know, why is that? You know, why are my numbers wrong? I suspect I see something different here. Well, I can, if I pick this up here, then I can, and if I click this, draw the plan view polyline, and then I choose draw here, that's going to draw the actual profile. So that's going to show me the difference in the numbers. And the draw plan view polyline should have drawn, yeah, it should have drawn that polyline in there, and see, it didn't. But anyway, you can, you know, you can use that. You can draw the polyline yourself first before you go into it, in which case, let's say, here's where I suspect there's an issue. I'm going to be interested in looking at this right here. I'm going to run that command, quick profile, choose surface file. There's my surfaces. I'll say okay. And now my prompt, either pick a point or center line or polyline. I'll type P for polyline. I'll pick that polyline. And there's now, whoa, I've got some serious issues going on with some of that in there. And then I could you know, draw it over here on the side and then make some decisions about it. So I can look at that and I say, well, you know, 20 feet, 40 feet, 60 feet. I see I've got some, oh, okay, I see what's going on. There's no data there. It's just assuming that, you know, it was jumping across there. And yet the reality of it is this blue line was my good surface and the green was the bogus. Okay. So that's really all that you need to take away from this whole thing, is that it's a great tool to evaluate from. And I want you to be aware of it as being there. You don't have to, you know, try to draw stuff and use the CAD system to try to, you know, turn it sideways and look at stuff all of there. You've got some really useful ways of doing this. You can look at everything that you select in 3 dimensions in the 3D viewer. This is one of my favorite tools. I do this all the time when I'm building surfaces. You can, you know, use that to look at surfaces as well as these contours. You can use this color by elevation. You can use the vertical exaggeration. You can add surfaces underneath the drawn elements. You can hold a shift key and use the wheel on the mouse as a way of just rolling things around to see if, oh, I see I've got a stray line down here that shouldn't be there. It should be up here, but somebody drew it wrong. You know, all of those different things, use them. Don't be afraid to take a look at this stuff in 3 dimensions, because, you know, that's, we live and work in a 3-dimensional world. And that's what we're trying to do with all this, is to model this stuff so that you've got some basis for making these measurements and designs and computations of volumes and such like that. Okay. Questions on any of that?
All good.
All
good. Okay, great. Let's move ahead, and we're going to talk about next. We're going to go through this exercise of learning a couple things, what we did with the points, and we're going to build a surface, and we're going to compute a volume, and then we're going to build a little alignment, which would basically be a roadway, and a little borrow pit, you know, and compute the numbers for that and get the design for that. And we're going to merge the two surfaces so you can see some of those tools. Now, that being said up front, I will preface that with, when we're putting this stuff together in this exercise, these are the bare minimalist tools coming out of the survey package only. If you have civil, which you do, Fred, you have a lot of way more advanced road design tools. But we're going to do it sort of the, we'll put quotes around the word manual way. It's nowhere near manual, of course, but it's just using the very minimalist stuff. It's the basics of what we need to get our stuff done. With the civil module, I'll give you an example. We're going to, in this exercise, we'll build a surface, and then we're going to build a horizontal alignment. And then to build our roadway, we're going to take that alignment, we're going to design a profile, and we're going to create a three-dimensional polyline that walks down the alignment in the horizontal plane, but it goes up and down following the profile directions. And then we're going to lay that down on the ground, and then we're going to offset to the left and offset to the right and drop it down a little bit based on the cross slope of the road. And that's how we're going to get our crown and our edges of pavement. And you can do that and keep building stuff, you know, go down ditches and go up walls, etc. So that's how we do that. When we're using civil, we can do not only that, but we simply give it an alignment, and then we give it a designed cross-sectional template, which includes the materials that are built under the road. You know, 2 inches of wearing course for asphalt, or 1.5 inches of wearing course, 2 inches of the binding, the binder. Then we got the sub base, and we got the well-graded subgrading, all the different kind of stuff that we've got underneath there, and they can accumulate all of those materials and add those up. But that's in the civil tools, and it's just, you know, as far as the fundamental tools, it's really nothing more than an extension of that kind of thinking, because you basically need a path that it's going to follow in the plan sense. That's our alignment. It's going to need a path to follow in the vertical sense. That's our profile. And it's going to need a shape, and it's going to push that across both of those directions. And then everything else it does is just add on gravy. And civil also has, and when I say civil, Marissa, this is stuff that's all included in takeoff as well. There is a sort of a subset of all this stuff called RoadNet, and it can actually do an entire network of intersecting roadways that will go through and compute an entire network of those. And if you change one of the roads, for instance, if you change its profile, raise it up, push it down, and if there's a road that crosses that or intersects it, it will pull that with it. Okay, and it will adjust those roadway crossings to make sure you're not, you know, got one sticking 20 feet up in the air. It's a really powerful set of routines, but it's no more complex, it's no more difficult than what we're going to do in this exercise, which is just basically drawing some lines, offsetting them to the left and right and up and down relative to our starting point, and then using them to build a surface from, and you know, tying all that stuff together. Okay, so in the sense of a road template, for instance, if I'm doing, and what we're going to do with our exercise, we're going to design the top surface of the roadway. So if I've got 2 inches worth of asphalt, how do I figure out how much material I've got underneath that top surface of asphalt? Well, I can take that one surface that I just made, which is the top surface, and then I can drop that surface and copy it down 2 inches and say, hey, there's the bottom of my asphalt, the upper part's the top, and then I can maybe drop that one 8 inches and say, yeah, that's the bottom of my stone underneath my asphalt. And so you can do all of those little things sort of individually, whereas those tools like RoadNet that's included in Civil and Takeoff put all that stuff together in a system that sort of works as a, you know, as a single, it's not a single push button exercise, but it keeps all that stuff tied together. So you don't have to keep track of so much. But in any case, let's learn the fundamentals and see where things go from there. Okay, so we're gonna take a peek at this starting on page 37, and we'll finish out our exercise here. And if we have some time at the end of the day, what I'll do is, since you both have the more advanced modules, is I want to show you what those tools are like and what we can do with them. But we can't really jump into instruction on them right now because, you know, you don't really have the foundational basis for it. I don't want to waste your time because nothing will stick, but I want you to see what your potential is so that you can, you know, see what's in your future once you get this stuff done. All right. So we're going to open a new drawing file called example 1. Actually, before we do that, let's talk about something. If you're back in this drawing, or if not, just open it or start a new one, it doesn't matter. But when you start up your session, you may or may not have noticed that it comes up with a wizard, and it steps you through, makes you choose a template. It asks you for scale and coordinate basis and all that kind of stuff. And that has to do with another setting that we didn't spend a lot of time on. And I'm going to go to it right now and just explain a couple of terms. So if you go to the settings menu and choose drawing setup, this is something that's sort of fundamental to everything in Carlson. You can figure out what it means, the difference between English and metric. Okay, we're going to almost universally be English in this country. I don't know if you guys are aware, you're both from Pennsylvania, but remember when PennDOT tried to make everybody go metric about, I don't know, 10 years ago? And they spent $2.5 billion rewriting all of the road and bridge specs and redesigning all of the CAD details and trying to get that done so that everybody had to do it. And the consultants just kicked and screamed and dragged their feet, and they finally gave up on it. They tried it for about 5 years, and so now they are no longer requiring it. They used to require it and then give you the option of doing them both ways, and now they just gave up. So if you work in Pennsylvania exclusively, you can, at least for the foreseeable future, stick with English. If any of you have ever worked in the metric system in this kind of work, it takes a little bit of getting used to up front, but once you do it, I did a job over in Africa back in 2000. It was a sewer job over there, and it is amazing how much easier it is, but you have to get your head wrapped around it, and that took a little time. So anyway, enough of that soapbox off. So we're going to stay with English. And with English units, now this is something else that's also going away. But we have a choice between using US survey feet or international feet. Now that, I say that's going away because they're finally, they finally screamed long enough and loud enough that they're going to deprecate that unit of measurement, the US survey foot. Now it's an important distinction, particularly if you use, or if you're working on projects that are linear, that are long, like several miles long, like along a highway. And when you're working in large coordinate systems like state plane coordinates, like the ones that this one is, if you look down the status bar, you see my coordinate values are in the millions. What that is simply this: the US survey foot. It is the definition of the foot that surveyors use, and it is based on there being 37.39 inches in a meter. And then that, you know, equates out to some conversion factor. The international foot is based on there being exactly 2.54 centimeters per inch. And that equates out to almost the same number, but out in about the 6 decimal places where it starts to differ. And that difference accumulates over large scale projects. And that's why you'll have some things and people will start scratching their head because things don't fit. But when you're working on local things like the size of our little project right here, it would make absolutely no difference. You'd never see the difference. But just be aware that that is now, at least for the time being, still a different set of units, and it's almost always done in US survey feet when it's done correctly. Sadly, it's not all that often done correctly. People don't really understand that there's a difference and they just haul off and do everything in feet. But when they start using state plane coordinate systems, they need to be aware of it. Almost all your surveyors are aware of it, so they're good with it. So anyway, I won't harp anymore on that. But here's the key thing that I want to talk about with this setup and this command. It's going to ask you for a horizontal scale. Now, you may be aware that when you're working in a CAD system, when you measure something, you're actually reporting back the distance of as if it's actually that distance on the ground. Now, in this case, if I measure, say, that roadway width down there, it might be 60 feet. But, you know, AutoCAD doesn't care, doesn't know, or doesn't even care about whether it's a foot or a furlong or an atom or an angstrom. I mean, it just doesn't care. It's unitless, but it tells you that it's 60 units, whatever your units are. And so that's what we decided. Okay, I'm going to call these units feet. And now there is a difference with architectural units because it sets up a subsystem of inches and feet. And the DWG world got it wrong way back 40 years ago, and they've kept it wrong all these years, whereas the DGN world, the microstation side, has a really nice solution to all that. Everything's done in meters and it's all translated out. But anyway, what this scale means, though, is that you're not drawing something. So if you draw a line that's 200 feet long, and I've got this setting that says my horizontal scale is 50, meaning that it's 1 inch equals 50 feet. That doesn't mean I'm going to draw something that's 4 inches long. I'm going to draw it here and give it a distance of 4. That means I'm going to draw it and give it a distance of 200. But if I were to plot it on a piece of paper at 1 inch equals 50 feet, it will measure 4 inches. Okay, that's all this scale is doing. And what it's doing with this number is right here, these numbers specifically. When you when you go to draw a piece of text, for instance, here's this text size. Using a standard CAD command, when you issue a text command or an mtext command, it's going to ask you for the text height. And that text height is in ground units. So if I'm at 50 scale and I wanted my text to be 1 inch tall, when I plot it, I need to make my text 50 units tall. Everybody follow that okay? And then if I decide later that I want to work at 1 inch equals 100 feet and I still want that 1 inch tall text, then I need to go back and change the size of that text to be 100 units tall. Well, Carlson approaches this in a slightly different way, in the sense that what you're going to do is tell it what scale you think you're going to be doing your final output as you're plotting. It doesn't mean that you're going to be plotting necessarily. But if I'm at 50 scale, then it asks me a couple of questions down here. It asks me for a symbol plot size, and it asks me for a text plot size. And then it asks me for a line type scalar, which actually I want that to be like so. Except really this is what I want. But anyway, so Carlson lets you answer this question for the symbol plot and the symbol size and the text size. So when you're putting points in that have point numbers and descriptions and elevations, or if you are annotating a distance and a bearing along a line, or annotating the stationing along a roadway or the area of a parcel, then what we normally do is we fill out the dialog boxes, and when it says text size, we don't have to keep track or remember what scale we're choosing. All we tell it are these numbers right here, and it's symbol plot size. So when you see the word plot size for text, for symbols, or even a line type scalar, you'll see that word scalar. All you have to think to yourself is, how big in plotted inches? So if I want my symbols to be 1/10 of an inch tall, I say 0.1, and at 50 scale, that means it's 0.05 ground units. Okay, so if I want my symbols to be a full inch tall, I don't have to figure out 50 and change it over here. I would just say 1 and say 50. Oh, shoot. There we go. I had accidentally hit the metric button. So I don't want to, so if I'm at 50 scale, and if I want 1 inch tall symbols, I just tell it 1 inch. It figures out that it's 50 ground units and sends that to the commands behind the scenes. But of course, I don't want it 1 inch. I want it 1/10 of an inch. And I'll take the text size to be 0.08. That's like a Leroy 80 for you old school people. Okay, so in setting this up, and any text that I create, whether I'm drawing a point or if I'm annotating something, by the way, if you're still in your drawing and you still have this box drawn, let's, or if you don't, just draw another box, do something. But I'm going to show you how this is going to work. Let's go to the settings menu, choose drawing setup, and set your drawing scale to 50. And set your symbol plot size to be whatever you want, maybe 1/10 of an inch. And then let's set our text plot size. Let's make it also 1/10 of an inch. And so when I do that, it automatically sets it to be 5 units, 5 drawing units tall. Okay, so make sure that says 0.1, this says 50. And we're going to say okay. Now, here's the benefit of this system is when I do something like, let's go to the annotate menu. And let's choose auto annotate. And it'll take a little while for the menu to pop up. Okay. We're going to illustrate another technique here while we're at it. So this is very common with all of these dialog boxes that you set things up like drawing profiles and sewer labels, that sort of stuff, is that you often see this little preview of what things look like based on the settings you have. Well, the first thing I want to look at though, before we get into this, is this down at the bottom where it says general settings. I'm going to click that button. And I'm going to see here that I've got, just in general, I've got angles, and that's going to be for things like bearings, distance tab, that's going to be like distance, so I can tell it how, how many decimal places I want, etc. But under general, it's asking me for my text size, and there's that number, that word again, scalar. That means plotted inches. Okay, so text size in plotted inches, let's make it 0.1. So notice it was different from what I set up here in the settings, but so this is just going to be my default value. And whether or not you want to use multi-line text, it doesn't matter. Let's just leave it checked. We'll say yes, and we'll say okay. to that. All right, so when it annotates this stuff, it's going to make text that to me is 1/10 of an inch tall. I'm at 50 scale. That's going to be 0.05, or I'm sorry, not 0.05, but 5 ground units. So 5 feet tall. If an inch equals 50 feet, then 1/10 of an inch is 5 feet. So now this down here where it says angle, there's a line, a space, a distance. That's because this down here is I've got, I'm on the first row to the left for my angle, and the first row to the right. And if you change this when you're doing this, see that's left and right of the line. That's not shown correctly. That should be up against the line. But if you look at it this way, and you can see sometimes that it's, you know, above or below. In fact, if we do them all on the same, let's put them both below, then you choose which is first, which is second. So if that's first, that's second. Or if we say the first row below, the second row below, it's going to look like that. But we'll just set it back to something like, oops, below, first. That'll be, so my bearing over my distance. All right, everybody got that? And you've got under the general settings, 1/10. Let's choose OK, and then choose that rectangle that you drew and hit enter. And then zoom in there and take a look at what you've just drawn. You've got text that is a bearing and a distance. If you select a piece of that text and look at its properties, either right click, choose properties, or if you have your properties open, select it, look at it, and see what its text height is. Right there, it's 5 feet. Okay, now, it also has a style of standard, okay, because that was what was defined in my, as my current text style. And you can set all that stuff up when you start a drawing, or you can put it in your drawing template. And you have a couple of key things in your text styles. There's my standard. I actually despise that ugly looking text. So I may decide to put this, you know, in as Arial narrow. And then I'll regen. So that's going to look like so. It's still 5 units tall. See right there. Now.
Hey, Ken, how did you bring up the text styles box?
See if I tell you that, I'll have to kill you. But that's spycraft. No, I'll tell you that. First of all, the standard CAD command, and this is what Fred has to do in AutoCAD, is you have to type style. And you can do that. You can type STYLE and hit enter, and it brings up the text style manager. And that lets you choose the style, make a new one. You choose the font that you're going to use. In fact, I think instead of Arial narrow, I'm going to change it to Arial. And so that's one way. But what I did was this IntelliCAD thing, and it's this button right here that's immediately to the left of this pull down for all the layers. And it's called layer control. You can also go to the view menu and choose layer control. And it normally comes up and lets you define all the things about your layers. However, it also has everything else that you can set, one of which is text styles. You can choose the different styles and set the different things about them. Okay, so I just chose standard. You could make a new style, do anything you want to, but let's keep it simple for now. Okay. And again, that's this button right here. And it lets you do that. And not only that, but you can attach external references. You can you know, have different user coordinate systems. You've got blocks throughout the drawing. You can drag and drop these from multiple open drawings. If you have more than one drawing open, you can take one from one and put it in the other. So it's really handy once you get familiar with that as a CAD drafting tool. For instance, if I open, let's go back and let me find something. Here's a production file. Okay, so so here's my my drawing. Okay, and I've got two drawings open now. I've got this one, I've got this one. And now this, I happen to be on a layout tab. Here's my model space, here's my tab. But if I go to this button where we had, now I've got two files. Here's the one I'm in right now, it's boldface. Here's one I have also open. And if I look at the layout, you see that right there? Remember that layout that had the Alcosan title sheet in it? If I take that and drag and drop it into the same category on this other drawing, the one that I'm in right now, and drop it, now I see that I have that as a layout. It's right there. So when I close this, come back and I see, oh, I have, there's my standard, but I also have this one called ANSI D sheet 1 that came from my other drawing. And there it is. And then I can, whoops, I guess I need to.
Ken, are we going to happen to go over like title blocks and getting things set up in that sense? Because I know for me personally, I don't know if it's just because of the takeoff, but I feel like I have a hard time getting things set up for like a paper space.
Well, actually, we don't generally have time for that in this course because that's really more of just standard CAD practice. And this is more of, you know, this is to learn the Carlson tools.
Right.
So,
I mean, if you have like a reference that I can like look at, you know, online or something, that'd be great.
Yeah, there are some good ones online. I'll try to put together for both you guys some resources. In fact, when you go, if you've, I don't know if you went to the link for that video yesterday that I sent you for yesterday's class, but when you click on that link, you're going to go to, you know, it's stored on my channel in YouTube. Now it's an unlisted link, so you won't see it show up in my channel listing, and it's just for you two because you're in the class. But there are some others that are on my channel listing that are sessions that I've done with a guy out in eastern panhandle of West Virginia. He's a surveyor out there, and he's based, you know, he's comes out of retirement. He didn't know any of this stuff, and he wanted to get started. So there's day-long sessions where we talk about, you know, setting up viewports and setting up title blocks and putting things in there. So it's really, really good to follow. But you know, he's paying, you know, a lot of money to have me show him that, because he's, you know, he's hired me on an hourly basis, you know, to sit down and to do those. And you know, hiring an engineer by the hour is not cheap, but he's doing it to really sort of give, and he has single devoted access. He's not, you know, sharing it among a classroom full of other people. So it's, but he's also agreed that I can post those videos there and anybody can look at them. So take a look at them. And some of them are 3 and 4 hours long, but the titles should be, and you can skim through them pretty quickly. And again, they're YouTube videos, so they're not going to take up a lot of room. So when you take a look at that, look at those things in my channel, and they'll have some things in there that will help you do that. Okay.
Thank you.
You are most welcome. I certainly am very sympathetic to what you're going through. I know what it's like. I remember doing this, trying to learn this, you know, years and years ago. But you know, in 2 days to try to get you know, an immersion and a taste of Carlson. There's just not enough time. In fact, we used to, back when a lot more people, you know, when we had classes in and outside locations, and a lot of people used to come for classes, and I used to do this all over the country. You know, one of the requirements was you had to know CAD, and you had to know it cold. You had to be really well versed in it, and it's not fair to the people that are trying to, you know, they're out buying Carlson software because the marketing hype says, hey, get this stuff, it makes it easy, you don't have to be an expert. Well, yeah, I mean, you sort of do, but it's easier and you can get a lot more done. So I'm very, very sympathetic to it. I know what you're going through and what you're asking about. So I'll try to point you in all those directions, and I'm certainly available if you want to do it, you know, at any point. If your company, you know, wants to, you know, pay for a day or two to come down and start you, you know, on, you know, say ground up stuff on how to do this with CAD to get things started. I'm not trying to sell that. I'm really not trying to push that on people because it makes it look like, you know, I'm a used car salesman. I'm not trying to do that, but I am available if that's something that you want to do. But, you know, keep in mind, it's not cheap. It's not exorbitant. It's just, it's beyond, you know, if your boss says, just learn it on your own versus, you know, spending $1,700 you know, for a day's worth of effort. Well, you know, he's going to say, learn it on your own. He's going to walk right in and leave you holding the bag. So I'm with you. I'll give you all the resources I can, but to answer the immediate question that you asked at first is, no, we're not really going to have time to do a lot of that. I'll show you what I can, like this, you know, where we do it. But in any case, that's the deal. Now, what I want to show you next is, because remember that text size that we just talked about, that text size scaler. If we go back to the settings now, drawing setup, and instead of making this a 50 scale, let's say this was, we're going to tell it that we had a 100 scale drawing. Okay, so we're going to say 1 inch equals 100 feet. So, but I want my text, and nothing happens, nothing changes there until you rerun the command. So now I'm set as if I'm going to plot it 1 inch equals 100 feet. So it's going to be a quarter of the original size. Let's go back to the annotate menu and auto annotate. Wait for the menu to come up. Leave the settings exactly like they are. And this is what I'm talking about, is that right here, I'm not changing this number right there. I'm leaving it to be 1/10 of an inch tall. And that's the beauty of how this works. And I'm going to choose that same thing. Now it's going to erase and redraw, and look at the difference. See how that worked? So it figured out that I want 1/10 of an inch tall text. And because of what I have set for the drawing scale, it computes that to be as tall as it needs to be on the ground. I don't have to tell it, or I don't have to go through and select everything and redo the text. Now, here is something else that you have not experienced with this stuff yet, and it ties back directly to a settings we had done yesterday. Select your rectangle, grab one of the corners and stretch it out of shape and see what happens. Because I took that shape and I annotated it with a Carlson command on the annotate menu. I said auto annotate, and you could do any of these. It could be, you know, survey text where you got building dimensions, or it can be, you know, angle and distance, like distance and bearing along a line. All of these different things. You can label areas, the same kind of stuff. And when those things change, those will update. If I say area by closed polyline, I'll do that. Put that guy right there. There it is. I exit. And let's just call it lot 1. And there's that based on that. If I change the dimensions of this shape, not only do those change, but so does the plot, the labeled area. So as long as I'm using a Carlson annotation command, the annotation will update itself as long as I have this set right here. On settings, Carlson configure, under general settings, it's where we said link labels with line work, this one right here. Those are the labels. Okay. So when that's linked, that would be done. Now it looks like I've sort of screwed that up a little bit by probably moving it a little too far. And so if you ever get a case like that where it's not exactly situated correctly, just go back and rerun the command that annotated it in the first place. And that was my auto annotate. And when it comes up, and I'm going to make sure that I told it to, where was it? Maybe, yeah, previous labels. I'm on my general settings, previous labels. I'm going to erase. And I'll just get it, and it'll just basically erase everything and redraw it for me. Okay. Now, enough of that. Let's move ahead here. And it being 10:30, actually, we're going to take us a little break. And when we come back, we'll pick up with this. We're going to build us a surface. We're going to look at things. Let's see. We're going to look at using points, point groups, building a surface, computing volumes, and merging surfaces, doing that little bit of a road design. So that's what we'll spend our afternoon on. Okay. And any questions that you think of as we're going through any of that, or that you can think of, over our breaks, be sure and yell. All right. So this is your time, your choice your chance to, pick my brain and figure out what's something that might be a burning issue for you guys at work. So, all right. So it is now 10:38, getting close to 10:40. Let's say meet back at, say, 10 till. Okay, it should give you time to get a few emails checked, and we will go from there. All right. Everybody good? Can you hear me?
Yep.
Okay.
Yep. Thank you.
So I'll see you. Yep. See you back here at 10 till. I will pause our recording. Okay, now can anybody hear me? Sorry about that. I had it on mute.
Yep, I'm here.
Okay, great. Looks like everybody's back. So let's dive into what we're doing. So as we can see here in our book, we're going to take a drawing that is basically just a drawing of a bunch of points that we're surveying. And it's called example1.dwg. So I'm going to come back to my Carlson side. I'm going to choose to open files. And I'm going to look in my folder where I'm working. Let's see. Sorry, I'm in the wrong spot. There we go. Carlson projects. Here's my fundamentals class, and it's example 1. And by the way, there's another file in here called example1 completed. And that's, you know, that is basically the end result of what you see in the book there when we're, you know, when you're doing the exercise. That's what everything should look like when you get to the when you're finished with it. So we're going to start with the example 1 instead, which starts out with just this, and it looks like indeed a bunch of Carlson points. And if I look at that and select it, I see that it is up here in my properties. It tells me I have 3 things. I've got 2 blocks and a point, and I suspect that, and it happens to be the case, that that is indeed a Carlson point. However, notice up here at the top, I'm in example 1.dwg, but my coordinate file says none. I don't have a coordinate file associated with this drawing. I don't have it opened as part of that. Yet I've got points in the drawing. So what's the deal? And remember, yesterday we were talking about points that have sometimes when we go to edit the points, you'll see that they have 2 descriptions. One says a DWG description, one says a CRD description. And that tells you, or should clue you in, that points can live in 2 different places. They can be in a CRD file, in which case, just like those surface files that we built earlier, they're external, they live outside, we can load them up in any other drawing file. Or they can also be drawn in the drawing, and that's what we do when we say draw locate points and we read them from a file. Or they could be in the drawing and then we no longer have the coordinate file, but they're just in the drawing. So how do we get these points into a coordinate file? And do we even really have to do that? Well, you don't have to, but it's always a good thing to do so that you can go back to it. If you happen to erase these files, you can always, or these points, you can redraw them from that coordinate file. So we're going to take a look on the points menu and see a couple of tools that we can use. And some of these are going to be down here at the bottom, these point utilities. They're sort of all laid out here as individual type commands. But if you look up here, there's a tool called Coordinate File Utilities. It looks like a little Swiss Army knife. So if you choose that, and it says, it knows immediately that, hey, you don't have a file open yet. So you need to do that first. So it's sort of forcing my hand to set the stage. So now I've got 2 choices, new and existing. Well, I don't have a file that's existing, so I'm going to go to new, and I'm going to call that, just call it well, let's not call it exercise 1. Let's call this one PTS points from drawing. Oops. Okay. So that tells me by its description where they're going to come from. So now I've got a file called points from drawing. And all of these are individual commands that I can run from inside of this one little dialog. There's my list points. That's the very same thing as draw, or the points menu, list points. Notice I have 0 points. I'll exit that. So here's how these are organized. On the left-hand column, there are commands that deal mostly with files. You can open a different coordinate file. You can copy or merge one file's contents into another. You can convert a file format. And just show you what that looks like. It's these, Carlson and C&G and Simplicity Systems, and then the Carlson GIS database format. So nothing really available there. There are some other ones, but ones that you guys would be using more often than not is this import text and ASCII file. And that's when you have like a comma delimited file. You would choose the file, choose the format, and bring it in, and it loads it into your coordinate file. Now that, again, is still not the case of what we're doing. The right-hand column of commands, as opposed to things that work on the entire file, these are things that work on this file, okay? You can get a report of duplicate points, you can rotate some points, you can scale them, you can list your points, renumber, etc. But in terms of the files and what we have, look at these bottom two choices. You can either update the drawing from a coordinate file. So you may have these points in here in the drawing, and yet in a coordinate file, they're in a different location, but the same point number. So you can reset them to what the coordinate file has, or you can update a coordinate file from the drawing. And that's what we're going to be doing, because our coordinate file has no points in it right now. So we're going to choose update the coordinate file from the drawing. How do we want to choose it? Well, I'm going to take all the points and update the point descriptions. There's no updating to worry about there. And any custom attributes, there's no, you just leave those set to what they are. They're the normal attributes, but if there were any custom attributes based on a different block definition, that's why that's there. Okay, so I'm going to say okay. And now here's where you can choose your points, but notice the line above it. You can select Carlson points, land development desktop, soft desk, En-ROADS, which is your microstation stuff, Eagle Point, Geodometer, Leica, or microsurvey. So we're just, and it will recognize that as soon as you select these, it will recognize all of those different formats and let you bring them in. Now, I chose that and selected my points. And notice down here on my command line, it says, okay, I tested 240 entities. I found 80, or I tested entity number 240. I found 80 points. That's because remember, each point has 3 entities in it. 80 times 3 is 240. Its highest point number is 2079. I'll list my points, all points. I look at that, lo and behold, there they are. And you see, I've basically got 2 descriptions. I've got a bunch of them that say B, and I've got some that say B-tow. All right, so that for right now, I'll be done with this, and I'll say exit. And if I look by inspection and I look around this exit or this thing, I can see, well, here's a point code. It's 390 feet, 394, 95, 396, 400. It keeps getting higher as I go toward the inside. So this happens to be a stockpile. And this B-tow, well, that tells me that that's, that those points would be the toe of slope as these were surveyed, okay? So did everybody get your points in successfully?
Yes.
Okay.
Yes.
So now, good. So now what we're going to do, what our job to do is here is we're going to make a surface out of the stockpile. We're going to compute some volumes and then design a little borrow pit and a roadway into it. So if you remember from our T3 global example, if we were just to select this stuff and build a surface from it, we're going to generate these long skinny triangles way out here in this edge. See where it dips in? So we need to sort of put a wrapper around this stuff. Same thing, we don't want them out in here. You could, it wouldn't really hurt anything necessarily, but let's say we wanted it to be nice and tidy, in which case we want to get that all contained. So what are our choices? Remember from yesterday, what did we do that allowed us to put a border around this? Remember the command?
It was shrink wrap, wasn't it?
Exactly right. Exactly right. So let's try that. Pardon me, I'm eating pretzels. So if I shrink wrap entities, let's go to draw, shrink wrap entities. So what I want to do, and you can put it on whatever layer you want, and I'm going to go across the gaps so that it will try to draw the lines, from point to point this way instead of going deep inside this area, okay? And I may have to do this several times, and I've got these different settings, but I'm going to leave it set to medium. I'll go across the gaps. A 2D polyline would be fine, but let's do a 3D polyline just to see. There's no real difference. I mean, there's a great deal of difference between the two things. One jumps to each vertex will be at the right elevation. Otherwise, it's all down at 0. But just in terms of building the surface, it won't matter. So if we do that and say, okay, and then it says, select the entity, select the points and line work to shrink wrap. So we're going to just grab everything and hit enter. And actually, that looks pretty darn good. With medium on.
Ken, I'm sorry, I missed that last step. How did you select those points again?
It said to select the entities. I just drew a window around them.
Oh, okay.
Okay. So, okay, so by inspection, if I look at a couple of things here, and I don't really know the situation here, but it could be that this boundary, see, it goes way down across here. Maybe it's supposed to have come in here and come back over to here and come back down. I can surmise that it doesn't because this says BTOE and not just B, so that's the toe slope. But I've noticed a couple of spots, one right here. Up here's a toe slope, over here's a toe slope, toe to toe. So all of these toes should be connected, but here's one that it jumped inside here. And I really don't want that one. So what can I do with that? You can either try to re-shrink wrap, go about, changing that medium or heavy or whatever the reduction factor is. Or what it really is a polyline. Now, if this were a 2D polyline, I could hover the mouse over that vertex and a menu would pop up and let me delete that vertex, and that would be all I need to do. But because it's 3D, I have to use a command to do it. And I'm going to go to my edit menu, polyline utilities, and it's a remove function, and it's a remove polyline is the pull right. And I want to remove a polyline vertex. Now look at that icon. You see the pencil eraser over top of a red dot. That's the vertex on the polyline. Look at the command above it, remove polyline segment, pencil eraser over a red segment of a polyline. So these commands are very, very helpful, and I use them a lot. But I hate to go, click, 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 click. And so I've learned that those icons are out here on my polyline toolbar, and I just remember the picture. There's the eraser over the little dot. So I'm going to choose that command. And that toolbar, by the way, is the polylines toolbar if you don't have it up. So if I choose that command, I select the polyline. So all of these little blips turn on, and now all I have to do is just pick near that. I don't have to snap to it or anything. I just pick near that and it takes care of getting rid of that one. So that's one. The command's still running, and I'm going to walk my way around the polyline, see if I see any other, here's another place. So I'm just going to pick near there, and that goes away from that one too, okay? That does say toe, so it probably does do that here. So that looks pretty good. Have I missed anything else? I don't think so. Now, that's one way that we can do it. I'll hit enter to finish the command. There now is a three-dimensional polyline. I'm going to select everything and go to my 3D viewer. And let's give this some vertical exaggeration. And I see that, well, yes, indeed, there it is. And I've got, you know, that one point right there is probably, you know, it's probably a little high in terms of what it really should be, but who knows? This is a pretty sparse data set. But anyway, I see that it's all got some elevation on it, and that represents the trace of the footprint of that stockpile on the ground. Let's put this back to A1 so you can see it's not all that high. Okay, so that all looks pretty good. I could then proceed to do what I'm trying to do. Well, let's talk about a couple of other tools. Go ahead and select your polyline and delete it. So I'm just going to select it and hit the delete key, or let's see here. Oh, there it is. Okay, so I select that. Now, there's a couple of other ways. So what if we had a whole big complicated mess of stuff and we couldn't really see it by comparison, but we did notice the fact that, you know, all the points that we're interested in say B-toe, but the ones that say B, we know are interior points. Well, you could decide to erase all these points. And remember, when you erase them from the drawing, you're not necessarily erasing them from the CRD file unless you choose to do so, and it will prompt you. But I'm going to do something even a little more radical. Let's just select everything, and I just drew a window around everything, and I'm going to delete them. They're gone. They're out of my drawing. But it's okay because points list points shows me that the points are all there. Now, I want to draw only the perimeter points. A couple of ways we can do that. If we go to points, draw locate points, and let's see, there's no real way here that you can see when it asks you to, you can draw a range, okay? Or you could draw all, but that would just put things back where they were. And if I draw a range, I'd have to know the point numbers, which I didn't pay attention to yet. But I've got this little thing over here called a point group. Well, that is a great time to set up a couple of quick groups. Let's go to our points menu and look at our point group manager. Right now we have no point groups, but we're going to create some. So when this comes up, this little system comes up and it has a couple of little menus inside of it, groups and points. Also, the buttons at the bottom are the same commands, just more convenient for you down there. So we're going to create two groups. I will hit create. The group name comes up and says new groups. And I'm going to call this footprint. Heck, let's make it a little more visible for you. So footprint, and these are going to be the points along the perimeter. base. Okay. Now, this is, if any of you are familiar with database selection, it's basically include and exclude. You build a set of points based on certain criteria. And right now, you may want to, if you include everything, that would be all points. So if I uncheck that, then I could say point list, edit my point list, and I can pick from a bunch of points, which I don't have them in there. I can select them from the drawing, but remember I erased them, I don't have them. I can select them from the coordinate file. So there they are. I can go through here and click and click and click and set all those up that way. Again, in this case, it would be trivial, but instead of using a point list, I'm going to choose a description, and I want to set from the list. So here's these ones that say B, 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 and then the others I have are B dash toe. I'll just select one of those and say, okay, so now B dash toe is going to be the things that create this group called footprint. And I'll say that. And I'll see that when I look at my points. Those are the only ones I have. Let's create another one. And this time we're going to call it interior. And these are points in the interior. And I will actually, let's do it a little differently here. I'm going to include all, but I'm going to go to exclude, and I'm going to exclude anything that starts with anything but ends with TOE. So that's what my little asterisk means. That's a wild card. So if it has the word TOE, it starts with anything and it includes TOE and it ends with anything, and I'll say save. And now, because I've only got two, you can see how trivial the exercise is. But if I've got thousands of points, it's a way to control your points by name, by group. Okay. Now, once you're in this manager, you can, insert them into your drawing. You can do all these different things from here. You can draw a line. If you draw a 2D line around the footprint, for instance, there it is. Now it didn't close it because it started at one, went all the way around it, and stopped at the other. I can select that, go to my properties, and say, yep, now it's closed. Okay, but again, that's 2D. Okay, or let's go to our points menu, draw locate points, and this time we're going to draw a point group, in which case we'll draw the footprint, and there they are. Now, when you shrink wrap,
Hey, Ken, can you back up a little bit?
okay.
I just created the interior group.
Okay.
And then just to show how you went and drew the outline again, did you just go to draw?
I was on this menu and said draw 2D line.
Okay.
And remember,
Did you right?
Go ahead.
Did you right click on that?
No, left click. These are just menus, just like up here on the top of the screen.
Okay, okay.
And those are all, not all, but they're the same, like create, edit, and copy. Those are the same thing: create, edit, delete, copy, import, that kind of stuff. Okay. And you can also you can sort by different criteria, do all kinds of different things with this. You can erase these groups from, in fact, let's do this. Let's draw locate points, and I'm going to draw all just to show you that. All right, so now there's all the points. Now, because we have the groups made, if I go to my group manager, I've selected my interior, and I'll go to my points menu. I'm going to say erase from drawing. And then when I close out of here, hit OK, you see the only thing you're left with are those exterior points. Okay.
All right, thank you.
So now when you go to shrink wrap, what you've got there, you won't have those little gotchas to have to fix, those little vertices to have to take away. It's taking care of all that for you. Okay. So that's a method of doing that. There's another one here called draw polyline by nearest found. Okay, and let's call this, let's put this on the same boundary layer. Okay, and so if you want to select the points from the screen or by point numbers, doesn't matter which, let's just say screen. I'll select all my points here and go boom, and there it drew the same thing, except I now have to make sure that I close it. Okay, now that's just a 2D polyline. Okay, so that's another way to do it. Now be careful with that nearest found, because you could have that distance set lower than the gap, so it wouldn't go across the gap. You could also find cases where, you know, maybe trying to see if there's a case here. I don't see it, but you could have, you know, a point that is actually, you know, maybe if this point were way down here and this line should come here to here and come down here and then come back up. Well, it wouldn't go down there. It would come across here because that's the nearest point, and it would come to here and then maybe down to there and then go up that way. So you may have some editing to do. All right. So, but in any case, all of this stuff is a set of tools that we can use to create the inclusion perimeter for our surface model. Now, the reason I had you draw this shrink wrap entity and I wanted you to choose it as a 3D polyline is this. I'm going to go back and recreate it. That this itself is a 3D polyline. So when it walks around and chooses to build a surface out of this, it's going to read the vertices of this polyline, which have elevation. Otherwise, if it's 2D, I can still use it as a bounding interior polyline or inclusion polyline, but I need the points to be here to be able to compute the surface. Okay. So now, how do you build that surface from the base? And here's what we're trying to do, for instance. We're gonna model that surface of that stockpile. But why would I be interested in modeling this bottom slice as its own surface? Any ideas? Why would I maybe want to do that? First of all, and this might come more into play with some of your work, Marissa, being an excavator, but what is a common task for a stockpile that you need to know? Like how much material is in that stockpile, for instance? Would you agree?
Yeah.
Okay,
Yes.
so how do you figure that out? Well, to figure out how much material is in there, you need to take some measurement of that as a surface, but then what do you compare that surface to? Well, if this were out in Arizona and that's sitting flat on the desert, then I can assume it's a flat constant elevation across the bottom, and the only surface I need is the up to the top and down the other side surface of the stockpile, and then I can subtract the elevation out from under it, and that's my surface. However, this stockpile might be on the side of a hill, so it could be sloping underneath it. So I can't just take an assumed elevation or an average elevation. It's not going to be very accurate. But if I can compute that shape, that is a surface from one edge straight across to the other edge. Now it's going to have some rippling in it, of course, because it's not planar. You know, the edges are up and down a little bit. But on average, it's going to represent the bottom of that pile. So if I compare that surface, let's say I call that my existing surface, and I call my stockpile my proposed surface, or whatever you want to call it, surface 1, surface 2, then the difference between those two surfaces is the volume of material that's in the stockpile. Okay, do you grasp that as a concept? And
Yeah.
now Carlson has, at least in the civil tool set, let me show you what the command is. Under surfaces, it actually has some things that were done individually, like stockpile, pond, and pit volumes. Okay? And you'd have to draw these perimeters and these break lines, et cetera, and calculate the stockpile volume. And that's if it's a stockpile versus a pond or a pit. Well, all in the world that was or is just a specialized case of what we're going to be doing anyway. So it's really a command that you don't really need. But some customer somewhere along the line, way back in Carlson's development history, said, "Hey, can you give me a command to do stockpiles?" And so they came up with that and gave it to them, and they've left it in the software. But really, all it's doing is taking this volume, taking the volume of everything else, subtracting the two, and say, "Hey, here's your volume." All right. So we don't need to do it with that specialized tool. We're just going to put our thinking caps on and realize that the volume in the stockpile is the volume between the base by itself and the stockpile as it goes up and down the other side. So to create that surface, we can do two things. You already know how to make a surface. We go to surface, triangulate, and contour. And right now, I'm just going to show you a couple of things. I'm going to uncheck this right triangulation file. I will use the inclusion. I will ignore zeros. And I'm going to draw the triangulation lines. I'm going to say, okay, here's my inclusion perimeter. No exclusions. And now the points and the break lines to triangulate. Now this is why I said if you draw it as a 3D polyline, it's going to read the elevations of that polyline. If that were 2D, I have to select the points also. So now I can get by with just the line. I'm going to hit enter to finish, and there's the triangles. Notice that they went, let me put all of these in the back. So now there's my boundary. Let me make that boundary so you can see it.
Hey Ken, I have white lines going in there. I'm assuming that I have my draw contours on.
Okay.
Is that what that would be?
Could well be. And here's how you fix that. Go back and run the command again. Check on contours and see if it says draw contours. If it does, uncheck it. And then go back to the triangulate tab. And right here in the middle where it says erase previous contour entities, make sure it says all contour entities. And then choose OK. And go through the steps again. That's one way. The other way you could have done it is to erase by layer. Remember that command up here on their layer toolbar? Where you could pick the layer from the screen, and that would erase them. Because again, all they are polylines. All right, now, we have here a surface that would be made up of these large triangular facets. And that would be okay. In fact, if I look at, well, I didn't say the surface. So, but if I select this and you see the grips that show up, so that's where the triangles form, is everywhere there's a corner or a vertex on that polyline. And that's fine. But the assumption gets made that from this point all the way up to here to this point, it changes elevation at a constant rate between those 2 points. Same thing from this point to that point, from this point to that point, from this point to that point, et cetera, et cetera. Now, it could have started here and gone all the way across this way to this point. And if it had done that first, then these triangle edges would not have formed because this was in the way. It becomes a break line as it is formed. Okay. Now, in this case, it doesn't really matter much, okay, because we're just using this to get some volumes. But sometimes you have to take a look at the way these forms, and you have to maybe sometimes go in and manually draw in some break lines that you know ought to be there. For instance, if this were a paved area and I knew that that was the edge of a sidewalk or a curb line or something, I would draw in that 3D polyline between those 2 points and have it sitting there first. So when I do that, in fact, I'll just show you the net effect of that. I'm going to go from there to there, and I'm going to erase by layer, get rid of these triangles, and I'm going to run that command again to build that surface. And there's my inclusion, no exclusions. Select that, and I'm going to also select this. Now watch what happens. You see there's no triangle lines that formed across it this way because I said, hey, that's a break line, don't go across it. So that's the essence of those. Now, none of that, and the difference it's going to make in computing these volumes is going to be fairly trivial. Now, with that, let's erase these one more time. Let me show you one other thing that you might have to do sometimes is when you're triangulating and you decide, well, all right, my surveyors went out there and they shot, this corner of the sidewalk, and they went 500 feet away and shot that corner of the sidewalk. But, I can't use those giant triangles up to that edge. I need some more stuff. I need to densify this feature. And you can either do it on the polyline commands on the edit menu, or you can go right in here as you're building the surface and do it only in memory. So when it builds the triangles. So if I say every 10 feet, drop a point there, I'll take this and I'll take this. Now notice how every 10 feet, it drops a point down and it lets a triangle form there. Not only there, but also between, let's select those and put them in the back. So here's this outside polyline. It went from this point over to this point, but it dropped a little vertex point every 10 feet. Okay.
Ken, I'm sorry. Can you show that one more time?
This polyline, when it originally, the first time we built the surface, the only triangles that formed were between the vertex points of this line to other vertex points across our stockpile or to its neighbor, okay? But what I did with this, and if I look at this line, I see it still only has the 2 endpoints. But when I chose to build the surface, I said, densify the break lines right here. And I told it every 10 feet. And that means in memory, go through here, find the data that I'm using and drop an allowable point, a position every 10 feet that I'm going to allow a triangle tip to form. Okay, so that's what it did. Not only on this line, but also even on this line, which you see only has a point here and a point here. But every 10 feet, it said it's okay to form a triangle point there. Even though I don't really need it, but that's one way to sort of help some things out. And I can even do Let's put that there. And did I read that correctly? Yep. Okay. So now I put another break line across there. And if I go to build that surface now, triangulate and contour, densify every 10 feet, choose OK. I'll get this. No more, no exclusions. The perimeter and the two break lines that I drew. And there now is a completely different set of triangles than what you might have otherwise. Okay. So it's just little techniques that you can use to help refine your surfaces. And again, I hesitate to show it to you with this example because you would never take the time and effort to bother with that. It's not worth it. There's not enough difference that it's going to make. But sometimes, like if you're working your way around a curved piece of concrete curbing or something, there, you know, you have to sort of get a sense of what can be done to smooth out and give a little more resolution to your surfaces. Okay. So this time I'm going to erase those triangles one more time. And here's what I'd like you to do. You have your 3D boundary drawn, correct? And if you have not put these in, just so that these numbers are going to match everything here, let's create these two break lines. So let's go to the draw menu and choose 3D polyline. And let's uncheck prompt for elevation or slope. And might as well use, well, no, let's uncheck use current drawing properties. And let's put a layer, we're going to call it BRKLN for break line. We'll say OK. And now when I sit on, I'm just hovering over that little elevation. As long as I see that little window pop up, gives me the point number, the coordinates, and the description, I know it's going to snap to that elevation. So I click there. I see it's anchored down. And I'm going to jump over here to this point and do the same thing and click there. So there now is that point. It's got 3D elevation. I'm going to do the same thing here. Draw 3D polyline. Same process from here to, oh, let's take it over to this one. Now, before we build anything out of this, we're going to verify this. We're going to go to our view menu, 3D view, drawing viewer. That means select things in the drawing, which is I'll select all of this. I'll finish my selection set. I'm going to let it load up. And when it does, I'm going to get my cursor, which is that rotational cursor. I'm going to position it in the middle where it's X and Y, and I'm going to push it up, and I'm going to make sure that I see things the way I expect them to be, and that they're not like one end of one of these white lines is not jumping way down to 0. Okay. So once you verify that, you may exit and know you're safe to continue. So now let's build the base of this stockpile as a surface. So let's go back to the surface menu, triangulate and contour. And this time I'm going to uncheck to draw the triangulation lines. But I will check to write the triangulation file. And I'm going to select it, and I'm going to type SP-BASE, stockpile base. I'll save that. I want to make sure that I am ignoring 0, and I will densify the break lines to every 10 feet. And I will say on my contour lines, make sure it's not checked. And then we'll say okay. And then follow my prompts. It says select entities, but I read the line above it. Select the inclusion perimeter polylines. So I select that red outline. In my case, yours may not be red. There are no more inclusions, so I hit enter to finish. And now it says select the exclusion perimeter polylines. I don't have any, so I hit enter. And now select the points and break lines, triangulate. Now I could just draw a window around it, but I don't need the points really. I just need the break line. So there's that break line, that outside break line, because it's 3D. So I select that one and that one and that one, and I hit enter and let it work. And now, if I go to my view menu, 3D view, surface file viewer, I choose my SP base. There's my triangles. And I look at it and see that it's a fairly flat, that's what I'm expecting it to be, sort of flat looking. It's not planar, it's not level, but it does have some relief, but it's relatively flat. I can go to my settings tab here and I can turn on display contours. Now this contour interval 1 foot, so that's every foot. So it's indeed on a slope. Okay. So that's why I'm having to build this as a base.
Hey Ken, how do you get it to show in like a fill color, like a full color? Like yours. Like how yours
instead of like that.
Yeah.
Okay. It's this icon right here, and it's on the view control tab. And it's the one that looks like exactly what you're trying to do. You want to color in the spaces between those lines.
Okay.
See? Now, if it's red or something, go to the model tab and open up the surfaces and right click and choose surface properties. And then you can set the color. Set a different one. Okay. All right, so we verified that we've got everything looking okay. We got a surface. Now, I'm going to go to points, and I'm going to erase points. And I'm going to select them by screen. That's my prompt. I have to tell it how I want to select them, screen, group, or number. Actually, let's just say group. And I'm going to erase the footprint points. Now, it says, do you want to delete them from the coordinate file? No, I do not. I want to keep them in the file, but I'll take them out of my drawing. Do I want to delete the point symbols? Yep. Now they're gone, and now all I have left are those 3 things that define the bottom of my stockpile. Okay. What defines the top of my stockpile? Well, remember it before, we had all those other points, right? So let's go to the points menu and let's draw locate points. And this time, let's draw a point group and let's draw the interior points. And there they are. Now, when we create this surface, we want it to create a surface that is, well, give it a little, here we go. It starts out here at this bottom edge and it goes up and over and to include those points that define the top of that stockpile. Now, when I'm asked to show it to select the points and break lines to triangulate. If I leave things as they are right now, what do you think is going to happen when I choose this? If I say triangulate and contour, and I'm going to change the name of my file right here, I'm going to select, and I'm going to call that stockpile instead of base. I'm going to call it stockpile top. And I'm going to say densify noise zero inclusion. Okay, I'll say okay. And now it says select the inclusion. There's the inclusion parameter. No exclusions. Select the points and break lines. Now, if I were to just drag a window around all of this, what do you think would happen? I mean, it would do what I'm hoping to do. I'm going to use these points, but, and I do want to use this perimeter, but if I choose this, like this, I'm going to go ahead and do this so you can see what the surface looks like. It computes the surface, and you might be lulled into a false sense of security. But if I look at that surface, well, good heavens, what happened there, do you think? And if I say turn off the, let's turn off the triangles, or the contours rather. And let's look at those triangles, and let's go back to giving it some vertical exaggeration so you see it. Now, do you see what happened? Look right up that line there and up this line here. Can you see what happened? Looking at this, does that give you an idea? Remember those lines that we just looked up? Because when I said choose everything to build your surface, it chose that outside edges, which I wanted. It chose all these points in the middle, which I wanted, but it also chose these points and treated them as break lines so that this point over here is not allowed to look over and see this point over here. This point can't look over and see this point, all those kind of things. This point can't create a triangle edge across that line. It can only go down to that line and then back up to this point. That's what made that V notch, that V-shaped notch through our data. So you have to be aware of what it is. And when in this case, and I can just leave that on that layer, I could freeze that layer, or let's go back one last time, triangulate and contour, leave everything as it is. We'll say, okay, yes, it's okay to overwrite. We'll choose the inclusion. There are no exclusions. Now select the points. I'm going to say everything here, except I'm going to, now it's still asking me to select. So I'm going to type R to remove. Now subtract entities from the selection set. I'm going to get rid of that guy and that guy. Now they will not be considered, only the outside edges and the points. And I'll say, okay, I'm done. There it is. Now let's look at that surface again, and we'll give it that same vertical scale. And that looks a lot more like what I would expect, okay? Still, you can see it's blocky and all that kind of stuff, and you could spend some effort trying to, you know, figure out break lines and such. We're not going to worry about a whole lot of that stuff right now. There's not a lot of density in these points. Okay. Now, if that's the case, and we have these break lines that we wanted to keep, but we don't want to use them necessarily all the time, then I would put them on their own layer, which I did. It's called BRKLN. And then I would maybe freeze that layer. So I keep the data, but they're not getting in my way. Okay. And now in the case, let's say maybe this is a true stockpile where trucks drive in here and they sort of wind their way around up here to the top of the stockpile, then maybe we would set up 3D lines to act as break lines like this. I'm going to call that break line top. Let's see here now. And let's do one more. We'll go from here to here, and here to here, to here. Okay, so now I'm not gonna do this, but you know, perhaps that was a situation you know, that defined sort of the, you know, the fact that they sort of wore a little roadbed into the hilltop like that. And we would either survey those in our original data, or we would try to construct it based on what we knew. Now, I'm not going to bother with all that. We have a surface. We know we have two surfaces. And let's refresh. Let's go back to the view, 3D view, surface file viewer. Let's choose the base first. There's our base. And let's go to the models tab and let's add a surface. So we'll right click and choose add surface, and let's add our stockpile top. There it is. And you can either you know, change its color. We can right click and choose surface properties, or let's make it a little bit transparent. We slide that opacity slider down. So now I can sort of see through it. So you see the bottom underneath it. And notice when I go up underneath it, I'm looking at the wireframe and not the solid. That's a setting also. It comes from this setting here, where it says shading mode, shade front, shade both, or shade back. So if I say shade both, then when I go up, you're going to see it's solid underneath. Okay. But now here's what to notice here. I want you to notice this up front before we calculate some numbers. If I look at these two surfaces, I've got the one, this top, I will hide it there. So here's this one. And you remember that little corner right there that sort of pops up? Well, look at it when I turn this one back on. You see, there's a little bit of where the base actually sticks up higher than the top does. Just a wee little bit. So when I compute the volumes between those two surfaces, I'm going to get a little bit of cut or fill, depending on which direction you choose to go in, comparing one to the other. That really, in practicality, should be zero. But when we get that, you just need to be aware of things like that. Just a little bit of estimation because of our density being a little bit, you know, a little bit on the paucity side of things. It's not all that, you know, I don't have a huge amount of data right in that defines that. Okay. So now we have two surfaces built, and I don't even really need these points to be in my drawing. I can do several things. I can freeze the layers, or I can even erase all the points. In which case I can say by group, I'll take those interior points. You delete them from the coordinate file, no. Get rid of the symbol yes. And now all I really have is the shape of that stockpile. That's okay. I've got everything else. I got points in the file. I've got two surfaces. So let's do a couple things with those surfaces. And the first thing I want you to do is let's compute the volume of that stockpile. So where would you expect to find that set of commands? Now, we've been doing everything based on the surface menu, and we're dealing with surfaces, and that's indeed where we're going to find it in survey. Now, Marissa, just because you have a specialized product with takeoff. Yours are going to be a slightly different process. You're going to do something here called, it's all going to be sort of on this takeoff menu. You're going to go down through this project checklist, and you're going to essentially make an existing surface, make a designed surface, and then you're going to do this calculate total volume. So that's all on its own set of workflow tools. Okay, so it's a little bit different than standard Carlson, but the result is the same, and the commands that it runs are the same. I'm going to switch back to survey now. So I want you both to get used to asking yourself, well, if I want to compute the volume of this material, how am I doing that? I'm building a surface. Where might I look? Well, I don't really want to look on the inquiry. Well, maybe you'd look on the inquiry menu. That would say, well, what's my volume? I want to calculate it. So you can try that and see that it doesn't do anything. But if you look at your centerline menu, for instance, well, that has nothing to do with volumes. So, you know, think your way through this. This stuff is as logical as it can be. So I'm going to go to my surface menu now, and I'm going to say, I want to compute some volumes. And right here are some choices. Volume by triangulation. Triangulation is the way we built the surface. We did triangulate and contour. So I'm going to choose volumes by triangulation, and one triangulation surface volume or two surface volumes. The one triangulation surface volume is exactly what we were talking about before, is if this stock pie was out in the middle of the desert in a flat lands like out in Arizona, and it was on a level base. You tell it an elevation and it figures out how much is above or below that elevation. That's not what we have. So we want to choose the two triangulation surface volume. Now, there are also commands like this two grid surface volumes and volumes by layers and all these different ways to compute those. And those numbers are going to be similar, not exactly the same, but the grid surfaces, when it builds a surface, it doesn't create triangles. It creates evenly spaced grid points, or like rectangles or squares even. And it just samples things only along those squares. Okay, you're going to very, very rarely use any of those grid surfaces. You're going to almost always use triangulation. And it's just a matter of computational capabilities now. We used to use grids because they were much faster and the computers weren't able to do the triangulation very quickly. Now that's a thing of the past. The computers can, you know, put rocket ships in space with no problem. We only problem with doing the computations. So let's do volumes by triangulation, two triangulation surface volumes. Now here's something to pay attention to. When this first comes up, it's all right, we're going to find a file. Now here's, when I say something to pay attention to, it's asking us for a file. The first couple of times you run this command, you're going to choose something and hit open, and then it's going to look like it comes back and didn't take what you meant to do. It really did. Keep your eye up here on this top stripe, because that's where your prompt is. It says select the existing surface file. Now, here's the deal. When we're computing a volume, we're comparing two surfaces, and it's going to call it existing and proposed. So our existing surface here is going to be that flat base, and our proposed surface is going to be the top. And we're going to look at the difference between it. So when it says select the existing surface file, I'm going to select SP base and open. Now see how this pops right back up in the same spot? That's why if you're not paying attention, you're going to say, hey, I already told you, and you're going to select it again, and it's going to give you zeros for your answer. But notice that the prompt has changed. It says select the final surface. So it's existing and final, not existing proposed, existing final. So now I'm going to choose the top. Say open. And use the inclusion polyline or press enter for none. Now, In this case, because these two surfaces have the exact same boundary around the edges of it, it doesn't matter whether I use that inclusion polyline or not. It will still end at those edges. Doesn't hurt to do it. So I'll just go ahead and select it again. No exclusions. And this is going to come up. Now, let me talk a little bit about the inclusion and exclusion. Another use for that would be, let's say you've computed an existing ground, you've computed the final grade out condition, but now you want to run your volumes and you want to see, well, how much do I have in phase 1? How much do I have in phase 2? How much do I have in phase 3? So if you draw those phase boundaries, even though your surfaces go over the entire site, you can restrict your calculations to those new boundaries and say, all right, this is the amount of earthwork just in this area. And so that's why they're very helpful and useful to know. Okay. So cut and fill, swell and shrink factors. Marissa, in your business, of course, you're going to deal with that all the time based on what the soil plasticity issues are. Same thing on the design side. If it's if you got a lot of clay, you may have some a few percentage points that you may want to adjust your volumes with. But for now, we'll leave them at 1. You can tell it, you know, which cubic feet, cubic yards, or both, square footage, acreage, or both for areas, and calculate elevation zone volumes. That means between this height and this height, you have that much volume. It can calculate those and report them. And if it says report tons, that's because this is a very common thing to do with stockpiles. Let's say it's a coal stockpile, and I'm out here on in my coal mine area. Well, coal is what, 80 pounds per cubic foot. So I put in a density, and then when it calculates these numbers, it's going to just multiply that out and give us the answer. So you can choose that or not. Or let's say it's 120, maybe it's a limestone fill. Now, if you write the tin difference, that's another tin file. And the difference of one file to the other is going to generate a file of not elevation, but a file of the amount of cut and fill. Okay, so that's one thing you can do that. But for now, let's just choose this. We'll say okay. And there's our report. Now, what does it tell us? And what can we do with this? Excuse me, I'm chomping in your ear. Well, it tells you what commanders run, date, time. And this is just text in a file. I can make edits to it. I can save, append to another file, print, etc. But I can also do a couple of other things. So first of all, here's my cut volume. So remember that I told you there's going to have a little bit of cut where that corner flipped up. Right there it is. So 0.02 cubic yards. It's nothing. Here's my fill. This is how much material I've actually got. And it's based on 120 pounds per cubic foot. I've got 5,700 tons of stone out there. There's my cubic feet, my cubic yards. Now here's a couple of numbers and how they play. The area that's in cut, and it's that little corner, so I can ignore that, but I've got 25,000 square feet in fill. And I've got that, well, there's my inclusion area. But so what it does is it reports, if it takes that area and turns it into a square, how tall would it have to be to compute the number of the amount of fill? It needs to be 3.81 feet. That's my average depth across that area. So here's my elevation change to reach balance, or to reach a same cut as same fill. is I need to lower that resulting square of 3.81 feet. I need to drop it down 3.77 feet. So basically 3.8 feet in both cases. I need to drop it down to that would make the cut match the fill. And it tells me how much volume is going to change per 1/10 of a foot of height change. Now here's how that number gets used. I'll give you an example. I was working on a job up in Owego, New York. It's up in the upstate part of New York. It's right down near the Pennsylvania line, but it was for Lockheed Martin, where they work on the presidential helicopters. And we had, I don't know, about an 8-acre site where they were going to build these new, I'm sorry, it was a 2-acre site, but they were going to build these new hangars where they were going to build a hangar space for 8 helicopter airframes where they're going to build Marine One. Well, the architect up there, who, as architects are, had his ego to satisfy. And, we had everything done, balanced, graded out and ready to go. And the contractor was there with us. He knew how much his dirt cost. And so we're sitting around the table at a review meeting. And the architect goes, yeah, well, that all looks good. That's great. So, but, what would it take to raise that site up, say 2.5 feet? So that you could see it sooner as you approach it coming up the hill on the entrance drive. There's the ego part. And he said, can we do that? And I said, well, yeah, we can, but that means you're going to have more fill. You got to haul in more fill dirt. And the contractor said, yeah, I can do that. It's X number of millions of dollars. The architect was flabbergasted. He goes, what, just to raise the building up 2.5 feet? And he goes, yeah, because he knew this number right here. He knew that every 1/10 of a foot, he knew how much cubic yards based on an average shape of that cube that was going to be required to fill that site. And if he had to raise it 2.5 feet, well, that's 25 of these 0.1s. And let's say it was like close to 100 yards. So 2,500 yards of dirt in that case, over 2 acres instead of, what are we talking about here? Half an acre. So 4 times that, it would be, and the numbers are different, of course, to make the balance. So he knew how much it costs him to bring in whatever the amount of dirt there was. And so he could do that quick mental math, because you say raise it 2.5 feet. He knew that number. He could just multiply it by 25 and come up with what it's going to take him. So the architect figured out that, well, maybe his ego didn't need to be satisfied quite so quickly, because even though it was government money, they didn't want to spend all of it. So anyway, that's what you can do with those. And here's something else you can do with this stuff that we haven't talked about yet. But all of these different buttons here are the same as these pull down menu choices. One of which that's really handy with this is, you see this right here, that's a piece of paper and a pencil, but it says output to screen. So if you click that and then answer a couple of questions about it over here, say okay, and then it's going to ask you down below, do you want to start, pointer, center, middle, right? I'm going to say, I'm just going to click here for the start, give it a rotation by default. It comes back up to this, but when I exit, there it is. And it's right there on the screen. Now, that's not what you normally see in a drawing, a volume report. But here's something you might. Let's say, these are all my control points, my benchmarks on the site. And I need to print those in my drawing as a coordinate table. Well, I just come over here, except I missed doing it. So I'll go back to my inquiry menu and choose display last report. Hit that again, and now pick and hit enter and exit. So now I've got a coordinate table that I can put in my drawing and show from my surveys to stake out. Okay. Questions on any of that before we break for lunch?
No.
Am I good?
Nope.
Okay. All righty. So go ahead and save your work, save your drawing. And when we come back, we'll finish up our little design exercise. We're going to do a little borrow pit, and we'll design a road, and we'll merge the surfaces and tie it all together. We'll draw some contours. You're going to notice when we've been building this surface, we haven't been drawing contours lately because that's really the last step of what I typically do. You're certainly welcome to, but that's why the command is called triangulate and contour, because a lot of people always do that. They have to see those contours or they're not comfortable with knowing what that surface looks like. But you know the secret that as long as you have that file, you can always generate the contours at whatever contour interval you want just by reading the file. And we'll do some of that when we come back. Okay. See you back here at 1:15. That'll give you a full hour and a minute or two. I will turn off the share and pause that recording, and I'll see you back here at 1:15. All right.
Sounds good.
Okey-doke. Enjoy your lunch. Okay. Everybody back with me?
Yep.
I'm here.
All righty. I had to apologize to you guys. I noticed when I put things on break, I think, neglected to restart the recording. So we're missing from today's saved video the gap between lunch and when we took our break. And there was a lot of good stuff in there. I really can do nothing more than apologize. I can't recreate it. So if it's missing, it's missing. I did turn it back on. I caught it this time, but I just overlooked it. I think what happened was I went back and I had originally forgot to turn the mic back on. And so when I unmuted the mic, I'm thinking subconsciously that I had restarted the recorder. I don't know for sure that I neglected to, but I think I did. We'll see when I get through processing it once it's done. Anyway, what we have so far, you've learned a few tools and some different ways of doing basically the same thing, and none of them are right and wrong. Like we could use the edges of those things to trim those contours. All of that stuff is perfectly fine. So as long as you can figure out a way to do whatever it is that you're going after, that is the right way. There's just some different alternates and some different ways to do things faster. Now let's talk about building a roadway. If we have, and we've gone through all of this stuff already now. So what we're going to do next is we're going to pretend that we're needing to build a road coming in from up here and sort of following down this pathway and turning into this area over here for our, where our borrow pit is, okay? And we will then generate a profile along that line, which will look something like this over here. You've already seen that sort of in our quick profile. We're going to be in the not so quick profile, so you'll see the actual profile. And then we're going to design our road like this with vertical curves in it so that we can build our road profile. And then finally, we'll create this center line along the original green line that we drew here in 2 dimensions. And we're going to create this as a 3-dimensional line based on this red design profile. And then we're going to kick it off to the edge over here and kick it off to the edge over here. Oops, I'm sorry. You know, kick one side off to the right edge, one side off to the left edge at a little bit of a downslope in each direction. That's why your contours are showing that looking like it's crowned. And then we'll target those edges back down into that original ground. And then that should be able to tie us into this all as a targeted surface. And we'll do some blending of all of that. Okay, here we go. So to design a center line, let's take a quick peek at the center line menus. On the center line menu, you've got a chance to design the center line where it's going to ask you to give a starting station and this, and it's going to, you know, as you step down it, you're going to put in all the information. But one of the choices is to simply take a polyline. Right there's your command, polyline to centerline file. So you can draw that polyline any way you want to draw it. Okay, so you can just draw a 2D polyline, draw it, and then you can use this command to turn that into a centerline file. And just like we've been doing with the surfaces, that's going to give us the file that we can use at any point in the future later on. Okay, so let's do that. Let's draw us a center line. Fred, how much road design do you as an engineer there at your company do? Are you familiar with horizontal curves and vertical curves and all that?
Absolutely. Yep. We do a lot of this.
Okay, good. And forgive me, you may be, you know, a graduate engineer, PE. I don't have any idea of your background, but sometimes I'll get, you know, they're like, you know, maybe a young new CAD operator that's just been assigned a computer and they're not real familiar with it. So I don't want to outstrip anybody's understanding, but I don't want to talk down to anybody either if you understand it. So you're good to go with that. How about you, Marissa?
What you explained is me.
Oh, okay, that's fine. That's fine. I need to know that so I know how much information to do. So when we design, we're going to design this little road coming in here. And what that means is when we get this road, like can you see that green alignment? See, we don't want to put in zigzaggy stuff. We're going to, where we change from this direction to this direction, we need a smooth curve in between. Okay, that's basically the limitation we have on this in a horizontal sense. There's not really a limitation, it just makes it for easier driving. And then the same thing, we don't want to have it go, you know, bumping all along this original ground. It needs to go up, and that's this scenario. It needs to go up and over smoothly, and then go back down and then flatten out smoothly. All right, so you see how we're going to use that to generate a smooth ride on our design, on our final product. So we're going to be able to do that as a polyline first, and then turn it into a centerline file. Now, I'm going to get this guy out of the way here because I'm going to be working in that area there. And I'm going to draw a 2D polyline, just plain old drawing a polyline. And I'm going to uncheck, use the current drawing properties, and I'm going to put this on a layer that I'm going to create called C-road-CL. And the color will be by layer, and I'll say okay, and right now it'll just be white. I'm going to say, I'm just going to click, click, and click. So I'm going to click a point here just as I'm coming in. And I'm going to click, I'll say over here, and then I'm going to come up into this part and, oops, sorry, I keep doing that. I'll do this again, C to continue, click, and now I'm going to click over here where I'm going to touch down. All right, so that's the beginnings of that, but notice I've got these nice sharp turns. I don't have a smooth little transition. So I'm going to fix that here. And we'll fix it a couple of ways. I'm going to sort of I'm going to put in these curves, and I can do it one of two ways. I'm going to put a couple of them in like this, just to edit the polyline itself. If I add, I'm going to hover the mouse over that. Now notice I drew that as a 2D polyline. We don't have any visual or vertical information yet. So I'm going to hover the mouse over that little middle grip, and I'm going to say add a vertex. And I'm going to come back here and just add one, say in there somewhere. So now I've got a vertex. And if I hover over that, I can sort of move it. Let me turn this snapping off momentarily. I'll just move it back there. I'm going to come down here. I'm going to add another vertex. Let's put one like so. All right, so I've got a couple of bend points, but again, they're not curves yet. Right now, as a CAD drafter, if I'm just doing this by CAD, I may say, well, I need to draw a fillet in here. And that's exactly what I'm going to be drawing, is a series of filleted curves. And let's put that up like that. So, and I can do them just like this, several ways. I can right click, convert to arc, and I can put, make these into curves like so. But what I want to make sure is that these curves are tangent, meaning they come off of this and are exactly tangent going into a curve, which it's a mathematical concept as to how that works. So yes.
When I hover over mine and hit add vertex, which it usually works, but for some reason it's not, I hit it and it, like I go to move it to a different point.
Yep. And it's not moving because your snapping is on.
Oh.
You need to either hold the shift key and right click the mouse and choose none, or turn your object snapping off momentarily, or choose, if you have the snap toolbar out, it's this one up here, the red X on the far right.
Okay, thank you.
Mm-hmm. So now, one of the ways to do this is to do what's called a fillet. And that, if you see, is over here on the right-hand side in my tool palette, or it's in this modify toolbar, same command. It's also on the edit menu. It's a standard CAD command called fillet. And what that means is it's going to take any two given straight lines that meet at a point, and it's going to fit a curve in between those two lines so that it comes off of the one tangentially and it lands on the other one tangentially. So I'm going to do just one of these. But the first thing that we have to do is to say R for radius. Notice our choices down there. So R for radius. And I'm going to give this a radius of, say, I'm going to click a point here and click a point here, and that showed the distance. And now it wants me to pick the first entity. So I'll pick this one and I'll pick that one. So that's now that radius. And I could do that for each of those points to make them circular curves. But there's an easier way to do it. Once we have this kind of stuff done as a drawn center line, and let me for right now go to my layers, C road center line. I will make that, let's make it green. And I want to load all of these. Center type. Center lines. There it is. Now, so one of the sort of neat things that Carlson does is it lets us turn that into a center line. So if I go to my center line menu and I choose polyline to center line file, it first asks me for the name of a file to write. So I'm going to call this one entrance road. I'll put it here in big letters so you can see it a little better. Okay. Now, it asked me to select the polyline that represents the center line, and it says the polyline should have been drawn in the direction of increasing stations. So if I pick that, because I drew it in that direction, and it shows me with these little temporary arrows, and that's okay. But if it's not the way I want it, if it was drawn the other way, it's going to give me the option down here on the command line to reverse the direction. I don't need to, I'll take it as it is. I can also type in A for ending or B for beginning and change the station value. For right now, this is not a class in road design. Just take the defaults. We'll take the beginning of 0, and there it is. And it gives us a report and comes up with some numbers, and it's made the file. Now, here's the thing. I told you that we want to have these nice tangential arcs in between there so that when we're driving along there, we're not having to stop and turn the wheel sharply and make these corner turns. That's for a roadway alignment. Now, what if this were a sewer line and we had a manhole here and a manhole here? Then those points are absolutely fine. In fact, we don't want to try to bend a pipe around a curve. We want to go point to point. So in that case, a sewer alignment central line would be absolutely fine. So don't get hung up on these arcs, but just for roadway design, just follow what we're doing here going along. Now, remember when we did the little square around our corner of our site and I had you label the bearing and distance, and then we selected it and dragged the corner around, and you saw those labels redraw themselves and recompute themselves. And I told you that was because on this settings menu under Carlson configure general settings was this link line work with points. Now here's something else that's going to happen. We have link line work with center lines. And here's what just happened. Well, if I select this polyline, I look at my properties and I see that it's a polyline. It does not say that it is a center line. Civil 3D would tell you that's a center line and nobody else can use it. They're going to make you buy an $11,000 design package to be able to work with it. But here's what Carlson does, it's because of that linking. If you have that as a polyline, now this polyline here is a contour. If I double click that polyline, what does it do? It brings up the p-edit command, which is what double clicking a polyline always does. But because I said centerline, polyline to centerline file, and I saved the file, When I double click this polyline, it gets intercepted and it runs the centerline editor. That's exactly the same command as if I'd gone to the centerline menu and chosen input edit centerline file, chose my file, saw the preview, and hit open. Okay, very same thing. Now, and it also works another thing very nicely is when you're sitting on these individual components, you have all of these controls. So if I sit on this incoming tangent, I can choose add, you can add different components, etc. Or I can say fit curve, and it's going to fit a curve right in there. And I'm going to put that curve in. Let's say I'm going to make that a 30-foot radius just to see what that's going to choose. And so it's going to, here's my data. It computes all the different components for that. I could even go into speed tables. It's got all kinds of stuff. So explore that when you get a chance, Fred. You know, it can flag if you're trying to make a curve too tight or what have you, but we're doing a stockpile to a borrow pit. We're not doing an interstate highway here. So I'm going to say, okay. And there you see it created that curve, but kept everything else the same. And I'm going to step next through and go down here to the next to the last line. And I'm going to put another curve in there. And yes, you can fit a spiral and then a curve and then a spiral. But again, for what we're doing, and let's make this one another, I'll make this one maybe a 25-foot radius. I'll say, okay, and now that's what that one's going to look like. Now watch what happens. I'm going to save it. When I exit, do you see what happened? It redrew itself because that is linked. And if I should happen to select this and drag this around, any changes I make graphically to this line are going to automatically update that CL file. So everything is perfectly good to go. Now, we are going to next design this as a centerline. You know, we need to design a profile so that we tell it vertically how that goes. So we did something before under this surface. We had this quick profile, and we said, look at a surface. There's our target. The stockpile pad merged. And then I usually just did click and click. So I could do click, 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 and click, and then finally click. And so that's going to look like that. That's going to be the shape of that, but it's not exactly the same. See, it's just where I clicked. Okay. If I said quick profile, same thing, but this time I'm going to say P for polyline. I'm going to click this polyline. Okay, now that is exactly all the way along that polyline. And that's what that existing ground looks like. Now, if I put it down to 1, no vertical exaggeration, it's not that extensive, but let's leave it at 2 so we can see it. So I get to the edge right there, and that's where I come down into the bottom of my pit. Right, so that's one way. I could now simply say save, and that's an existing ground profile. I could do it that way. I'll hit exit. I could go back and say, surface, come down here on the profiles, and I could say create profile from, and these would be profile from grid or triangulation surface. So I'm going to say from the triangulation surface. Okay. What happened? Create profile from. There we go. I must have missed something. All right. So choose a grid or triangulation file to process. Well, there's my merged surface. Say open. And now it gives me a little bit more control other than just choosing that polyline. I want to say I want railroad definition curves. And if I link the profile to the triangulation, what that means is it's either going to automatically update or it will ask me if something changes, or I'll leave the linking off. It's just like those other linkings where the label's updated or whether this or the alignment updates itself. So if I say link profile to the triangulation, if that ground surface should happen to change, it's going to automatically update this file that it's getting ready to save. So that's what I want it to do. I could generate stationing by another center line. There's no need for any of that. I'm going to leave it at that. And I can create offsets by generating offsets, to the left and the right. Okay. But I'm not going to do that part yet. I'm just going to take this profile, these roadway curves. I'll say okay. And the profile file that I'm going to write, I'm going to also call that one entrance road. Let's see if this is going to do what I want to do. I'll now, because I have a centerline file, I can either pick the center line itself, or I can type CL and choose that file. Okay, so it made a profile along that pathway. And if I look at that, I'm going to see it. So I'll go to my center, or not center line, but surface menu, and I'm going to say input edit the profile file. And there's the one I just made. You see what it looks like. I'll say open, and that's just like we saw before under that quick profile, but with a little bit more change to it. Okay. So that's actually the existing ground. Okay, and so I've got a couple of things here going on. I can make several different types of profiles, just a generic profile or a roadway profile, sewer line profile, pipes, crossings, and circulars. We're going to come back here and we're going to use a road profile. But the first thing I'm going to do is I'm going to give these reference center lines and reference profiles. So I'm going to say exit for right now, and I'm going to show you why I did that, because right now it says entrance road, that's my profile file, but as you saw, that is the existing ground. The design ground is what I really want my profile to be. So I'm going to go back to surface, and I'm going to say input edit profile file. Now, Fred, on the civil tools, the highway design tools under that profile menu are a lot more extensive than this. You have a little deeper tools. Okay, but this will get the job done. So I'm going to input it as a profile file. And this time, instead of using that as an existing that I'm going to edit, I want to go to the new tab. I'm going to create the design. Excuse me. So I'm going to call this one entrance road design. That's my design profile that's going to have my vertical curves in it. Now notice it's empty. So I'm going to use it to come up with my design. And you see right down here, I can choose the type. I'm going to choose roadway. And I'm going to tell it to use a couple of reference guidelines. So my reference center line says none. I'm going to hit set. I'm going to choose that's the horizontal alignment. I'm going to choose from my reference profile now, the one that I built before. That's this one. That's the existing ground. And it will show itself in here as a reference. So that's what it looks like. And I'm going to click this. Well, I'll leave it at 5 because you need to see a little bit of that vertical relief. Okay. And so now all I need to do is start putting in stationing and elevation or slope percent or vertical curve lengths, sight distances, etc., etc. I've got all kinds of things down. I've got settings where I can choose how I'm going to hold the slopes, whether I'm going to display sight distance or K value is going to be my guiding principle. I can use vertical speed tables where I can look things up that tells me how much sight distance I need, what K value I need to be able to drive at a particular speed. You know, all of this kind of stuff that I can do right now, a little beyond what we're doing. So we're going to generate the vertical curve design for this bit of roadway. So the first thing is I'm going to do is I'm going to click right in here and I'm going to start with station 0. So that's the very first station. And I don't know the elevation exactly. I can sort of guess it, but I do know that the depth I want is going to be 0. So right there is that 0 depth. And I'm going to go to the end. Now I do know the end station. If I look down here at my reference center line, I see that it goes to station 1 plus 62.7465. So I'm going to choose in that station 162.7465. And I'm going to also put that depth at 0. So now uh, 0 to 1, 62, 74, 65. Let me see if something's. There we go. It apparently going all the way to 74.65 was just pushed it just a little bit too far. It was a roundup issue. All right, so 162.74. In fact, if I put it right in here is where it touches down. And you notice up here, it's tracking, it's telling me what that is. And I look in there and I see where those crosshairs are. That's stationed at 1 plus 47.689. Let's call it 1 plus 48. So let's make it, we'll back up. Not only have that one there, but we're going to sit on that and we're going to say, add row, which is a button over here. And we're going to call that 148. And we'll keep it also flat at 0. So now I've got 3 points of interest. I've got the first one here at the beginning, the second one, which is out here, the third one, which is at the end. Notice the little green markers. So now I'm going to want to put some more in here. So I'm going to go over here to my 25 station. So my 25.
Hey, Ken, I'm still at my end point. I'm not getting it to come up with a
Yeah,
distance in between.
back it off a little bit short of that total distance. The problem was I had the same thing. When I put in this number, 162.7465, it would not compute an elevation because that number is a little bit shy of what it really is. It's a rounded up number. So I was sticking off the edge of it and it didn't know how to compute it. So just give it a
I did. My total number is 147.0021, and I can push it all the way back to 135, and it still doesn't give me anything.
Did you go over to the depth column and put in 0?
There we go. Thank you.
Yeah. Mm-hmm. So that's what will compute the elevation is I know I want the depth to be 0 when I start and where I land. These others are going to be different as I go along. So I'm going to do some eyeball work here in a minute. And I'm going to say at station 25, I want to put, let's say I came into that at just a very slight uphill grade. Let's call it, say, a 2.5%. It's going to, hope it's not going to blow up on me. Oh boy. Well,
Mine was actually doing this whenever I was trying to move that vertex,
okay.
and it like totally crashed. So I don't know if it's just Carlson in general or what's going on.
Well, now there's something that's causing that to happen. I wouldn't call it Carlson in general necessarily, but it is due to the programming. I've had much more stability out of this stuff than I have out of Autodesk products myself. However, that being said, there are certain gotchas that if you don't do something exactly right, it's going to sit here and spin itself into a slow death. A lot of that is also Microsoft's fault because of Windows. But it doesn't do any good to say he said, she said, and it's blame the other guy. All we can do is fix what we're doing here. So to fix that, let's see if I can exit that. I sure did, and it killed everything. Now, all is not lost. And if you click that and you close out, if you don't get it to close out, come down to the status bar, right click and choose Task Manager. Find it in the list, select it and choose End Task until it goes away. Then go back to Carlson. Load the file again. In this case, it was called example1. There it is. Now, it's there in the state of the last save. Remember my centerline file? It's no longer in here. However, what can I do? I can go to the centerline menu and I can draw that centerline file. And when I do that, I'll choose the layer to put it on, which I have to create the new layer again, which is called C-road-CL. And I'll go ahead and label it and choose OK. Choose my center. Ooh, maybe I shouldn't have labeled it. There we go. So I'll now find this and make it green. And I'm going to load. These center files. And I'm going to take that. There we go. All right. So now there's my center line. Let's go back to my input edit profile file, which will be a new file, which will be entrance road design. I'm going to make it a road type. I'm going to set my reference profile to be entrance road, my reference center line to be entrance road. So there that is. And I'm going to start off here and I'm going to make station 0 have a 0 depth. And I'm going to go to the end, which is at 162.7465 or thereabouts. The profile goes 7419. So let's say 162.74, also 0 depth. And let's spread this out and go to 5 and zoom in a little bit here. And at 147, so I'll sit here, add row, 147, also a 0 depth. Oops. Ah, okay. It is 0 depth because that's where it hits right there on that white line. I don't want that to be 147. I want it to be 147.666. So 147.75. Let's make that. 0.75. And let's make it 0 depth. There we go. All right. Now I'm going to come in here to station 25. Station 25. And let's give that a let's see, what is my let's see, let's make that a 395. 396. No, let's keep it 395. So that goes down a slight little downgrade. let's maybe change that to be a positive upgrade of 1%. Oh, crap. No. 0. 0. 1. Oh, man, this is so bad. Yeah. Let's set that to be that. So that makes it 3.5%. I don't need it to be that steep necessarily, but well, what the heck? Let's actually change that up to, what is that station? 43. So we'll make that 45. And we'll make that elevation 390. 7.5. There we go. It's a little bit better. That puts my slope at less than 5%. It goes up to the top. It comes down here to the bottom where it flattens out to 0 there. So if I say 125, one, two, five. $390. Let's make it 395. $394. 94. Ah, shoot. Dang on it. Fit. Wow. 0, 41, so 390. 4.75. Let's call it. Okay, so I've got something that's approximating what what our original ground was. And if you see, as I move this up here, on this one, it's not going to do it. The road design tools, you'll see a little tracker going along. But in this case, let's just wrap this thing up. So I'm going to start here. Let's stick with a 5-time vertical. So as I go back and forth to these different places, now Marissa, you see that I've got a little green marker that tells me what, which one of these points I'm on. And there is no curve in between there, just like we had out here in the horizontal sense. This is the vertical sense. So I need to put a curve in there. So I'm going to sit on that point, and I'm going to come over here to the vertical curve column, and I'm going to give that a distance. Now it's going to be from where it starts to where it ends. And that distance for this particular thing is probably going to be 50 feet. That's sufficient. So you see now I've drawn my vertical curve. That little pink spot right there is the crest point, and you see it down here as well. And now I'm going to go down here to this one at 125. And I'm going to give that a distance also of 50 feet. And it says, aha, it's too long. The maximum length is 45.5. And the reason for that is because it hit this one that I said to keep that at that elevation. So I can back this up a little bit, maybe make that 35. That should work. And then that puts it down there flat to flat. Okay, so now I've got a nice mathematically smooth vertical roadway design. These curves happen to be mathematically, Marissa, they are parabolas. They're not circular curves like they are in the horizontal. There's a lot of research as to why those are. And Fred, I don't know if you've ever done so or not, but apparently there are places, I don't know of any in the United States yet, they may be, but there are places that are using circular curves in vertical road design. Now, I know all of the AASHTO roadway design guidelines, that doesn't give a very comfortable drive. Your parabolic designs vertically are not only easier to calculate, but they're easier on the ride comfort. But that's just a trivial little something to think about. All right. So now that I've got this design done to my satisfaction, I'm going to say save and exit. So now I've got a center line and I've got the existing ground underneath it. But what does that thing look like in 3 dimensions? And that's where I need to go to my profile tools, and I want to turn that profile into a 3D polyline. So if I choose that, then I'm going to give it a name, and I'm going to, or for the layer, and I'm going to call this let's call it C-road-CL-3D. I would say okay. What am I doing? CL. And now I'll choose my design profile. And there it happens to be. Now here's what this all looks like. If I select it and start to push it up, you see how that green is down at 0? Okay, and I'll reset this back to plan view. And if I select everything here and view it, that's what it looks like. And if I give this a vertical exaggeration, add my ground surface to it, you can see that there's my design coming up here. It sticks up out of the ground, but then it needs to go down into the ground, underneath the ground a little bit, until it goes through the embankment and winds up flattening out here on this bottom. Okay, so that's what I need to do, but I need to figure out how much of this ground out here do I need to whittle away so that I get that roadway built. Okay, and that's what we're going to do next. So I've drawn this line. That's my 3D polyline. If I look at it with my quick profile, this time I'll use this as my source. I'll select it. There it is. Remember our design. And now you see it's traveling right along that line. Okay. So now what do I know? If that is the constructed center of my road, I need to have 2 lanes on either side of that high crown, and they tend to go off at a cross slope of 2% or sometimes a little bit more or less. But I need to offset this line to the left a whatever width for my lane that I want. I'm going to make these, oh, I don't know, two lanes, say 12, let's call them 2 12-foot lanes either side. So if you want to offset a line or a polyline, if I have this, it's a 2-dimensional polyline. If I want to offset it, I'll go to standard offset. Let's give it, say, 12 feet. I'll pick it, go to the right, pick it, go to the left. Right there's my 12-foot offset for that. That's all well and good. However, what happens if I want to offset this 3D polyline? Standard offset. I'll keep it, let's make them 10 feet just to be a little bit more conservative here. I select this and it says unable to use the selected entity. Please pick again. That's because AutoCAD, from a CAD perspective, using just the CAD tool, standard offset, it can't offset a 2D polyline. It can only offset flattened 2D geometry. But Carlson gives us a way of doing that. If I can find it in the survey, and here it is. On the edit menu, because I'm dealing with that drawn 3D polyline, one of the things is to offset a 3D polyline. So when I do that, I have a couple of choices. I can either offset this 3D polyline to a constant elevation, that's this choice up here in the upper right. I can offset it to a particular surface so that it hits the ground at a certain spot, or, you know, all kinds of different things I can do. But what I want to do is I want to do it by interval. And again, I'll keep my projection perpendicular to the slope direction. If you recall from our design pad template, that was our conservative limitation. So I'm going to say, okay. The horizontal offset amount now, that's what I'm prompted for down here, is 10. It's my lane width. Now, how do I want to set the vertical? I can either type in an amount, or I can set it as a percentage, or as a degree of a slope, or a ratio. So if I type P for percent, I now need to tell it the percent away from this line that I want to go either up or down to set the edge of the road. So I want to be high in the middle, so water sheds to the sides. So I'm going to send that down as a negative 2. Now, some of you may ask, why am I using 2.08%? Bonus for whoever gets that question correct. So there's that one. And then I'm going to do the same thing. I'm going to select it again and go out to the other edge. So now I've got it selected. I want to venture a guess. On why 2.08% instead of 2 or 2.5? Well, the answer is 2.08% is a 1/4 inch per foot. And that's what most roofers know as the minimum that they need to use to drain water. Otherwise, water will sit on the roof. So that way it guarantees that my water drains to the side. Now, I could do all kinds of other stuff. I could take this, now that I've got the edge of the pavement, I can design in a shoulder and do a ditch and do all this kind of stuff to, you know, help really refine this as a roadway. I'm not going to do all of that. I am, however, going to do one little thing here. Remember this pad that we designed was at an elevation of 394.5. I'm going to, I need to see that line now. I got rid of that outline of the pad itself, not the surface outline, but the pad outline. I got rid of it when I had to reset the file. So I'm going to go back to my surface menu and I'm going to contour from 10 file. And I want to choose that borrow pit. And here's what I want to do now. I'm going to turn the labeling off. I'm going to go to this, and instead of by interval, I'm going to say contour a specific elevation. And that elevation is going to be 394.5. And I'm going to put it on, say, this layer here and say okay. And why did it not? There's something I missed. The borrow pit, contour and elevation. Oh, shoot. Sorry. It wasn't that, it's this. 394.5. There we go. Okay, so there's now my original pad. Now the reason I'm doing that is because right here, when this road edge gets to this edge right here, I want that road edge to be at that elevation and not down below the center line, that 2%. Right now, the center line is at that elevation. I want these to also be at that elevation. So I need to raise them up just a little bit to make them flatten out to where they get there. So I'm going to do that in this fashion. I'm going to select this as a trim agent. I'm going to come down to my edit routine, and I'm going to wonder where on earth they put the trim tool. On this menu, I know where to get it. I can either type it or I can right click the mouse or I can pull it off of the toolbar. Huh. Well, all right. I've got that selected. I would just right click the mouse and choose trim, and I'm going to trim off these edges. And I'm going to set this elevation. I'm going to set the elevation of that line to match the elevation of that line. Same thing with this. I'm going to set, so I'm going to start in here and I'm going to work my way up to where I hit that elevation right there at that same, at 394.8. So in the civil tools, again, I've got all kinds of very elegant tools that I can do that with. But for right now, all I can really do with this is manually edit those elevation points. I know what that is. It's 394.5. So if I select that and look at my properties and look at my vertex location. So if I step through here, I see that's 394.64, 0.6, 0.5. And you notice from there, if I go to the next one, it's going to be 42, 37, 31. So I'm going to back it up to, I see that 0.45, 394.5. I'll go to this next one and I'm going to change that elevation to 394.5. I'll go to the next one and make it also.
Sorry, I couldn't hear what you said.
Oh, I thought I was talking to it. I'll go to the next one and make it 394.5. I'll go to the last one and make it 394.5. And I will be done with that one. Okay. I'm going to do the same thing with this. I'll select my vertex. I'll get to the last one. I'm going to back it out to right in there for their 60. Let's make that one 394.5. Go to the next one. 394.5. Go to the next one. 394.5. And go to the next one. 394.5. Okay. Now, like I said, the roadway design tools let you put in these, curved returns and tie all this stuff in. So, but again, what we're doing is slightly different here. So I now have three three-dimensional lines that represent the center of the road and the two road edges. And I've got this borrow pit pad area. But I need to remember how we did the borrow pit to begin with? We had all those 3D lines that we turned into a surface. Well, I need to make a surface out of this roadway and add it into all this as well. So I could do that. I can make a surface out of this road and it would just be the road itself. But how do I get the edges of the road to tie into this existing ground? Do you remember what we did when we did this design pad?
You merge them?
Well, yeah, that's correct. I'm glad you recalled that, but I'm talking about before I got to that point. How did I make the pad surface itself? Remember, I told it that pad had an elevation of 394.5, and then I said I wanted to go up at a 3-to-1. Okay, remember, and my target was my existing ground, which was that stockpile top. So I had to make that, and remember the little green outline and the red lines? That's where I want to go with these, but I want to use these yellow lines to do that with. And the command is on the surface menu, and it's called Design Pad Template. Now, this is why I wanted you to sort of think this through, because it's not a closed pad, it's just an edge, but that doesn't matter. And here's how this is going to work. We'll go to that surface menu, choose Design Pad Template, and we're going to again target a surface. We're going to go to the outside, except it won't matter because this is it's not going to be closed. And I'm going to come down here, and on my pad layer, I'm going to, well, we'll just keep it called pad. That doesn't matter. So now, what am I going to do with this? Target a surface file, and we'll go to a particular ratio. I'm going to say OK, and pick the pad polyline. Now this time I'm going to pick the edge of the road. Click, select my target surface. There's my stockpile, not my top, but my merged, which would also include the bottom of the borrow pit. I'll say open. I'll take those 3-to-1 slopes again, And now, because it's not a closed polyline, it doesn't know to go inside or outside. It says which side you want to go. I'm going to go to this side for that one. So I'll click over here. Uh-oh, it found a problem. I wonder if I'm too close to the edge over here. Let's do, this. It might, just for expedience sake, let me. Cut this back a little bit. All right. Three, one, three, one. Let's go to that side. There we go. I was just too close to the edge and it went off the edge. Okay. I'm going to repeat, or I'm going to say no for that. And now I'm going to repeat the command. And I'm going to get the other side of the road from here, looking at merged. 3 to 1, 3 to 1. I'll go that direction. And now there's, and everything's in cut to get me to that point. And I'll say no. Okay, now I want to create a surface out of this stuff. So I'm going to go to my view menu and I'm going to isolate layers. I'm going to pick the green, the red, and the yellow. So now there's what will become my surface. I've got these things which are closed polylines, but I need to really sort of close across this gap and then close this gap to this gap to this gap. And here's how I'm going to do that. Excuse me. I'm going to, first of all, get rid of that. A little too hairy. I've got a couple of things here too. I want to maybe get rid of that and that and that. I'm really just simplifying a couple of things here. And then I'm going to reconnect these points. I'm just grip editing and snapping to those endpoints. All right, so, but now, like we've seen before, we need to shrink wrap this to build a surface out of it so it closes off these edges. So I'm going to draw shrink wrap boundaries. I'll make it just a 2D. Medium's fine. Everything's good to go with all of that. So the line work that we want to shrink wrap, and now it turned all those others back on because it needed that layer to be on to draw this boundary. I got some crossing break lines. Oh, they're pretty small, so that I'm gonna not worry about those. All right. So this one, I'm going to remove that vertex. So now this is going to wind up looking like, oh, it's 2D. I'm sorry, I was going to show you what it looked like in 3D. But anyway, that is the extent of that as a surface. So let's build that into a surface called our roadway. Go back to our surface menu, triangulate and contour. I'll go to the triangulate tab. I will turn on write the triangulation file. I would choose it, and I'm going to call it entrance road. I will use an inclusion exclusion area. I will ignore zeros. I'm not going to contour it. I'll say okay. I'll now follow my prompts. I'll pick the inclusion. There are no exclusions. I'm now going to select this data and say okay, and it's going to come up with these two errors. Very slight. Right there, just a little crossing. See where that little problem is right here. I need to get rid of that vertex. So I will select this and get rid of that. There we go. Now, once again, triangulate and contour, leave everything exactly like it was. Yes, it's okay. Select the inclusion. There are no exclusions. Grab the data. Hit enter. There's still one spot here. Zoom back out. And clear that one. Okay. One final time. Triangulate contour. Okay. Yes, it's okay to overwrite. Select the boundary. No further boundaries there. Select the data. And there's still a crossing break line, but it's less than a 10,000th of a or a thousandth of a foot. So I'm okay with that. I'll leave that alone. I will look at that surface, and there it is. That's what my road looks like. And I can now get rid of all of these drawn 3D lines. If I want, I could have put them on a layer and frozen them. I could have done anything I wanted to do. I will go back to my center line just to draw it. Oops, sorry. Try it once again and uncheck label. So there's my center line. Let's restore these contours and let's now draw the road contours. So contour from 10 file, entrance road, draw the contours. This time go back to contour by interval and let's change this to 1 as an interval. There's 5. We'll change the layers back to C as future. Might as well. Do these, one label per, we'll say okay, and no inclusions, no exclusions. There's my contour lines. Oops, they are 395.96. Okay, let's try that one more time. Labels, 0.06, all right, see topos, contour text, contour. Ah, good heavens. Topo boundary, I want it to be see topo center. And this is see topo center IDX. Labels, okay, there we go. No inclusion, no exclusion. Contour from tin file, road. See topo, contour text, contour, topo, contour, ones. That matters. Say okay, no inclusion, no exclusion. There we go. So there's my 395 and 396, 397, back down to 396. And to see how all that looks together, the last final thing, and I promise, I'm sorry I've held you over a half an hour later, I just realized, my apologies. But if you go to the surface menu and let's do triangulation file utilities, just like we did before, let's load our base file, which this time is stockpile and pad merged. Let's go next and let's merge into it. I'll go ahead and turn that on like so. Let's merge 10. Let's do the roadway, which is entrance road. Oops. So there now you see that road with the edges cut into it. And we'll now come over here and do a save as, and we'll call this one just plain old merged. It's everything merged. Save that, say okay, we'll exit that. We'll select all of this. We'll go into our viewer and sorry, we'll select all of this, go into our 3D viewer, and let's tone that vertical exaggeration down, back down to 1. Let's go here and add our merged surface. There it is. And you can see right in there as that road comes around, as it comes down that bank. See where it used to come around like this? That bank went straight across over here. We're in the purple part now. It has cut through that bank. Let's see if I can. There you go. You can see how it's cut down that bank so that we land in here at that same elevation. Okay. So that is basically our steps to do all of those things, to tie all those things together. Okay. Questions, anybody? Other than, can you go now? Yes, you can. So,
No, I got a good grasp for it.
okay, good. So, here's the keys. There's a couple things. I sent you the other night. I'll send you again later tonight or tomorrow, whenever I finish the processing on the videos, links to those. When you get to YouTube and see those, check out the other Carlson videos in my channel, and some of them are quite long, but they have some very complex things, and a lot of them are in terms of putting plats and designs together, in terms of drawings and stuff like that. Paper space layouts and how to use annotative text, different techniques, transformation, or coordinate transformations, all kinds of things that may help you out. You may be a long way away from making those happen automatically. And also keep in mind, particularly you, Marissa, since you're sort of new to this game, I've been doing this for over 40 years. So, I do it every single day. You're not going to, at the end of 2 days, be able to, jump on that same horse and ride it just as fast. So there's going to be a bit of learning that you're still going to have to go through. So what I'm going to try to do is look at those things in my YouTube channel. Take a look at them. Also go and look at Carlson's YouTube channel. And so I'll show you what those things look like. And they may even have a better approach to it because they're going to help you do specific things and they're much shorter. So if you look at the help menu in your computer right now, and you go down to this online training movies, and you choose that, it's going to go to Carlson's YouTube channel. See, this is Carlson software. Okay. And there's all these different playlists, and it's sort of, you could sort by category or search, rather you can search by a couple of keywords, that sort of stuff. So that's one place. And if I close that back and go back to get that out of the way there. If I go back to my, instead of going straight to the online training menus, if I go to the Carlson website, if I'm not in my Carlson software, I can also go to the support tab. Let's see if looks like maybe they've changed some of this. Under resources, I've got brochures and documents, downloads, movies right there. If I click movies, okay, no, it all funnels you here. That's okay. All right, so now it used to be you could select by category like survey, civil, constructions, and all that. So you can look down through these things. Now here's an idea of, there's field to finish. Let's see if I've got playlists. How about videos? If there's any kind of things that's track, Carlson 2020, there's an overview, registering a laser scan. Some of these things will have no relevance to what you're doing. Here's how to export surfaces and points to Civil 3D. Here's underground mining. Again, nothing. Here's something in German. Field to finish. So, but if you go to playlists, or if you're not sure what you're looking for, let's say I'm going to search, and I want to talk about takeoff. All right, so here's now a CAD file takeoff from start to finish. This is how to do takeoff using your takeoff software. This is, and that's like using R10. Now this one is how to use Takeoff Suite 2019. Now that you see is an hour long. This one is what, 48 minutes. Some of these other, here's one that is 3 minutes long. Carlson Takeoff Overview, 3 minutes. Okay. 31 minutes, getting volume reports in Carlson Takeoff. So there's all kinds of help here, and they're much less than these 6-hour videos that you've got links to off mine. However, feel free to use mine. Feel free to use those. One final, here's one that's going to be really helpful for you, Marissa, PDF importing. So you get files in from engineers, sometimes that are PDFs, and that's all you get. So what do you do with them? How do you turn them into drawing files and create takeoffs? Okay. So that's a resource from that help menu. It's always going to be right there. Now here's another one. Or there's two. There's my channel, there's Carlson's channel. Go to the help menu and go to the Carlson manual right there, the very first one. And this is the help system for Carlson manual. You can always look up anything to do. Let's say we are looking in, you would look under construction module if you're using the modular system, or you do it in your takeoff system. But let's say we wanted to do areas of interest. Okay, so how to set up areas of interest, and it steps you through the steps here as part of this stepwise approach. You can also, when you're doing certain things like triangulate and contour, and you say, oh my gosh, what happened? You know, I forget everything that we did. Well, most of these commands have a help button at the bottom. And when you choose that, it's going to take you to that part of the help system. Okay. Bottom with some of them have some, they're really, really extensive and have some great graphics to help you. Some of it's dated. Some of it's, you know, they try to keep it up to date. And if it hadn't changed much, then they just keep the old stuff. But you should be able to find your way through all that. So those are all things that you can use, but there's something else in the help system. If you pull down the help menu and choose the Carlson manual, and that's the very first, let's go back to that. That's the very first choice. Down here on the table of contents, over in the left, choose contents. And over here on the toward the bottom, there's this little section called tutorials. There's some CAD basics. It might be real helpful for you, Marissa. Getting out of a command, how to, what does enter do? How do you repeat commands? How do you select items? Properties, layers, you know, all those things you may know, or you may need some review on some of those. If you're a surveyor, how do you enter a deed, make a plat, field to finish, intersections. Here's your contouring, digital terrain modeling and design. That's exactly what we've been doing these last couple of days. Okay, using shrink wrap, using break lines. And they got some other examples, and the examples that they show you here are, I believe, from the example files that get installed when you install the software. I think that's where they come from. Contouring break lines and stockpiles. Again, there's that whole concept that we just went through. We didn't look at this one yet, but we did look. There's our stockpile that we had been working on. A dozen tools for surface design, how to do these different ones, how to draw a 3D polyline, draw a 2D polyline, how to draw a design pad template. Boom, there it is. And they're taking these road edges and pushing them out to the existing ground. So they have a little scenario. It's how the road appears in 3D using all of these tools that they've stepped you through. And there's a whole site, you know, here's a pad that they've cut out, and a roadway that they've cut the road, another road, and they've had to fill in up here. So These are all really excellent tools that can help you do this work, and they're a little more piecemeal than what trying to remember 2 days worth of having the fire hose turned on you. I know, and I can appreciate what you all have had to go through in these last couple of days, because it's a lot of information and it comes really, really quickly. So with these resources, that with the training manual and those examples and the data files that you have, and if you ever need to go back and get those data files fresh to start over again, just use that link from that email I sent you. But take your time when you can work through them a little more leisurely and go through them point by point. Go to my channel, watch those videos, go to this help system under the tutorials. And for you, Marissa, there are, right here's your takeoff business, takeoff site net from start to finish. Okay, that shows you. And the whole thing is a little bit different. It's based on layer membership, but follow the examples and you're going to see, well, that's really a lot different than what we did these last 2 days. But yes and no, it's not really different, because behind the scenes it's doing the exact same things, but it just has a different set of tools, and they're found in little different areas. Okay, but it's exactly the same stuff. You're building three-dimensional solid models, or surface models rather, and you're comparing one condition against another condition. That's all this stuff is. And the rest of it is just spending 40 years getting good at it. Okay, so that's some resources to use. Okay, fair enough for what you think, guys?
Yeah, I thought that was really good. Thank you so much for all your help.
You are most welcome.
Absolutely.
And
thank you.
yeah, and now you guys, stay in touch. When you get stuck on stuff, pop me an email. If it's something I can help you with very quickly, I'll be glad to do that. That's part of what you get when you sign up with MSoft, to, because we not only do this training, but we'll help you out when you need some help. If it's something that would take, a day or two worth of hand holding or consulting or additional really intense training, then we have to stop and talk about, an additional consulting issue. But, onesie twosies here and there, just please feel free to ask. And even if it's something that's going to take a lot longer than it should, and I'll let you know that, and I'll point you in the right direction to either find the answer on your own, or we can talk. You can talk to your company and see if they want to, go into a little more extensive stuff. So because, as much as I would love to, I just can't afford to work for free. I wish I could, but so you have that. Now you also have, and a lot of people don't realize it or take advantage of it, but you have free technical support. You have access to tech support at Carlson free of charge. It comes with being a Carlson customer. So again, in the help system from their website, there's a phone number for tech support, or you can send them emails and all that kind of stuff. So you have access to them no matter what it is, and they can help you there. Again, we'll be your first line of defense. Send an email, send a request. Stay in touch. We'll take it from there. And I think, Marissa, no, if I'm not mistaken, you have either already signed up or you're interested in signing up for these next upcoming classes.
Correct.
And now I think, you and I've talked, Michael has probably talked to you about it. There's a possibility, because they're so close to us right now, that they may or may not happen when they're scheduled to, if it's just one person signed up, we can't afford to do that. We lose money just teaching that. We really lose money only having two people in a class. but it's so close to break even that we'll do it as a public service. And then just work a little harder on the next one. So hopefully Michael will have some more success, get some people done. If there's anybody that you know of at any other companies or whatever else, and if you want, if you know about anybody else in the industry that you want to try to talk them into coming into those classes, please feel free to do so. That will help guarantee that they'll be done. But I also don't expect you to be out trying to sell classes for us. That's Mike's job. I'm the technical guy. I don't do any of that kind of marketing other than I know that it's something that needs to be done. So all that being said, stay in touch, stay close, call us, email us, do whatever you need to do, figure out what's going on. And if we need to reschedule stuff, we'll reschedule it. If it's something you can dig out on your own through these other resources, by all means, do so. Not trying to lock you into any direction or to push you away, either one. So the overall goal is to make you all successful in what you're trying to do and comfortable with the tools. Okay.
Sounds good. Thank you so much again.
All right. Well, folks,
again.
I appreciate it. And I will wish you well. I'm going to turn off my stuff here. I'll stop the screen share. I will stop the recording.